Good morning, Mr. Cash.
Yeah.
Good morning. How are you?
Good. This is James from Hong Kong.
Yes, I know. How are you, Mr. Cho?
Good, good, good.
So, is there something you'd like to start off with, Mr. Kesh, or should we go to maybe a general question from someone, or launch into the Malta Group's work?
I think we came here to see the work of the Maltese we didn't see last time.
Right. Okay, let's see what we can do with that. You can see the movie's still uploading, so folks can have a look at that.
Can I speak now?
Yes.
Yes, well, now we're trying to test the speed with the tachometer. As you can see, Manuel is holding tachometer. We still have to balance the sphere, but as you can see, we can slow it, we can put some more revolutions, we can go up to 4,000 revs, but that is all we can do at the moment. Okay then, thank you again.
And I'll show some pictures on my screen while Emmanuel can perhaps tell us what progress they've been having. Are you ready to say something about that, Emmanuel?
Good morning, Mr. Kasher.
Good morning, Badel. How are you? Yes, can you hear me?
Yes, I hear you.
Yeah. Before we go ahead, I will send back your email to you today or tomorrow.
Okay. Take your time. Anyway, I'm sorry Joe is very sick today, but I can do the talking.
Are we going to see anything today?
I've sent a video and pictures. So, but presently we had to take it out in pieces, because we're doing an alteration to try to isolate the upper sphere from the lower sphere, so that you can use it as an anode and a cathode.
Mm-hmm.
And then we will be able to pass current through it to try to get it running, This we're going to try to do. I think it's a good idea. Hello?
I am listening. Can you repeat again, please?
We're trying to get it running, open the plasma and then ionize it, We're trying
I don't understand the process you started, and I'm watching it anxiously. I see what you're trying to do, but what do you call it? I wait and see what results you get.
We have to try it and test it,
Yes.
The process we are trying, do you think it's in the right direction?
I don't know. It's your idea. It's your idea. I've never worked this way. I've done a test like this, maybe not exactly, but similar or in that direction, our result wasn't what we were looking for. Maybe we didn't have the right environment, but not this way. We tried to enforce current through the plasma, not through the, what do you call it, through the structure. But I'm anxiously waiting for 2-3 groups to see what their ideas is coming up, how they work, and yours is one of them. I don't know how you're going to do it. You have a concept we got to look at. I cannot see your video. Okay. Let's see that one.
The concept is like
I only see the rings. This is a brass core. It's not a copper. It's a brass system.
it's brass, yes, brass.
What mixture? Do you
I
know
don't
the
mixture
alloy,
because we order
the
them.
composition? Okay. So I've seen the pictures. It's very nice. I like the way you produce things. I've been to your factory. I know your capabilities. It's
Yes,
very, very
what we're going to
interesting.
do is the lock nut, you know, the nut, we have to make it of nylon so that
Why?
the upper part will be isolated from the lower part. And that way we can use the upper part as an anode and the lower part as a cathode. Then we
You
try to
mean
pass
which part? You mean the rings?
the half round, you know, the half sphere.
Yes, but you're going to make the rings in plastic.
Not the
Make a
rings.
separation.
The nut, you know,
The
one
nuts,
that
the
will-
rings, the two rings which you screw to
rings.
each other, the 2 halves.
the ring will be brazed with these spheres, the
Mhm.
upper sphere and the lower sphere, and then there's a ring like a lock nut that goes over the threads, you know. I said if we
You
do that,
can. There is an easy way to do it. You get your 2 rings.
yes,
You don't need to put a plastic. We did this very recently for an aluminum piece in the system which we had to do. What the guys did here, they took the rings and they got them oxidized, and you get a total insulation without actually putting it in a piece or changing it to plastic. You take your rings to a specialist who oxidize them, and brass is very easy to oxidize, and oxidization gives you total insulation even with a high voltage or high current. You don't need to make another piece or a plastic piece for separation. It takes a couple of days. I don't know if you have the facilities in Malta.
yeah, we have,
Yeah, you just get the 2 rings totally oxidized. They do it in a specific way that you achieve full insulation. You don't need to put another piece, because if you put a plastic or change them to plastic, you could get all sorts of problems. But you keep to the same material, you get a full insulation, and you see it. The problem is what I don't understand is why you're trying to create 2 different currents in 2 hemispheres. The plasma will decide its own characteristics. This is something which has puzzled me. 2 things I'm watching your work with is, one is the ionization, and one is you're trying to create an anode and a cathode within your sphere to create ionization of the plasma. It can be done in much easier way, much easier way. And I'm watching to see what it brings. Don't forget, this will come very clear to you very rapidly. Once you reach a plasma condition, and then you reach opening of the plasma, if you get to it, if you have any connection like electrical connection to your plasma, you will see that the plasma will rotate on its own and will change polarity very rapidly, especially if your motor is running. You have a brass here, which is totally matter. I wonder how you will contain plasma. there are too many people on the call again. So that's why I'm very anxiously, I'm interested to see, even it means if your system works, I'll come to Malta to see how you do it. But the principle you're using is very interesting. It's another way of looking at it. It's beautiful what you've done. But I'm watching to see how you're going to achieve. You're using a high voltage and then separation, but how you're going to contain the plasma in the center.
We were going to use DC, not high voltage, low voltage, DC.
Yeah.
Then we have to keep increasing till get results.
I said I'm watching very interesting. I'm watching your work with a lot of interest because your approach is different. There is a school of thoughts, or is the way I have thought about it before. Would microvolts and amp create the same condition? The other way to maybe you might test is use Hall's which means you continuously squeeze the plasma or them gases inside, that you force them to reach a position or a condition. You will see very rapidly, if you reach what you're targeting for, that you get a change of polarity very, very rapidly. And one of the things to do to secure your frame to somewhere before you start, because I've lost a reactor this way. I lost a reactor years ago through change of polarity over the called vacuum magnetic field pressure. I'm student learning from you.
Mr. Kesh, I had a question about that. It's along the same lines. Would you call plasma as a positively charged or a negatively charged field?
A plasma is fully charged. There is no negative or positive about it.
So it's a neutral charge?
No. Depends, you redefine the positive and negative. Positive is what they call is magnetical field, which is going outwards. Negative is gravitational field pulling inwards. Depends how you increase one and decrease one and what position you are in respect to the source. There is, to me, this is the way I define things. There is a big change, or you have to accept a big change. What you like the way we redefine gravity or we redefine other things. You have to redefine. I'm hearing myself back. You have to redefine the positive and negative. What is negative and what is positive? What you define as a positive, what you define as negative. Depends where you are in respect to what you're looking for. You're positive or you're negative. I do a lot of work with this in respect to certain parts of the what they call it, reactor technology, and I use it quite frequently, quite often.
So if you positively charge, say, like what Emmanuel was saying, an inner sphere and an outer sphere, would that not keep the plasma away from the matter?
I don't think so. This is my way of thinking, the way I look at it. But points where there are the two imbalance, or the zone when they become imbalance in respect to the environment which they give or they take to, this is what we call the upper atmosphere as a plasma of the Earth. So you have a zone which you got neutrality or near neutrality, one reaches the other one, or balancing. But beyond one on one side is negative and the other side is positive, which way you want to be. But there is, I talk about these things because I've seen them over years in experience. And when I do the experiments, I see them by experience. I've learned how and the way you do things. When you start running your inner core and outer core, you will find out if you reach a real plasma condition, you lose control of your inner core and outer core. They decide what the speed they go. They decide if they go slower or faster. And then you know you're really working with the plasma. The rest is very easy to talk that you do this or you do that, or this can be done or that can be done. In one of the experiments in the lab recently with our guys, they were puzzled how suddenly the speed goes up and it comes down and it gets faster and it goes slower and it gets faster and it goes slower. And you see you have no control over the motion of your cores. We see this regularly. I've talked about this before. You see suddenly, if you run your core and you see the core, the middle core goes to a halt and your motor is there, kind of there, just stop. You achieve beautiful plasma balance between inside and outside. This is what the world of the scientists don't understand. They never seen it, they can't explain it, and they tell you talk a lot of rubbish. If you run two-core system, if you run a plasma condition, and you see one of your cores, you don't touch anything, you don't touch your voltage, your motor is running at same speed, everything is the same, and then you suddenly see rapid increase in the speed or reduce in the speed, and then you see one core is totally goes on a halt. What happened? The motor has burned. No, this is a beautiful, perfect condition confirming you achieved balanced plasma on two sides of the reactor. Or you achieved so much energy release from one of your plasmas that is releasing rapid energy to the one of the cores, and the core gathers the speed, because the speed cannot come from nowhere. It has to come from absorption of dynamic energy, magnetic fields in motion. So when you run these cores, if you have a double core or you have a single core, and you see suddenly increase without doing anything with your cores or reduction, and I've seen it hundreds of times when we used to have windows on our reactors, the inner core just goes like a slower speed and it stops. On the first times I used to panic, what happened, why is it not going there? And over years I build up a habit, I just wait and I watch it. Half an hour, I go for a coffee, I come back, it's still there. And then you see the reactor goes a little bit to the left for a few rotations, and then it goes a few rotations to the right, and then it starts going one rotation a minute, and then it goes up. When the balance gets disturbed, and then your reactor comes back to normal speed after 3-4 hours. Then you understand a lot of people talking, creating a plasma at the room temperature, cold plasma is nonsense. You just laugh at them. You understand this is all a bunch of rubbish because they haven't seen it. I had this discussion with a professor online yesterday and he couldn't understand. So because he's a professor and he's a physicist and he's been to CERN, this was a lot of nonsense. But to you, when you run your reactors, you see it, you understand how easy it is to create plasma and a dynamic magnetic field plasma that interacts. If you put a current to one side, you drain it. If you put a voltage to another side, you drain it. These are the things I've done. If you see the old reactors, they're full of holes. I never forget one of my colleagues in Sharif Tehran University. He said to me, do you know what's the problem with you, Mehran? You make too many holes or put too many things in the reactor. You get a chance, you make a hole. We don't have the knowledge till we don't make these holes and put electrodes in and see the behavior of plasma. We could never learn. With the brass or copper or a steel reactors, you don't have that opportunity, because otherwise you have to drill, continuously put this, put that in, that out, and make it seal. With the plastic reactors which we have, we can do that. We just make a hole, we finish, we fill it in with a, what do you call it, the resin, and that's it. Next hole somewhere else. If you see the original reactors which I work with, they're full of holes, they're full of electrodes hanging all over the place, because I had to learn about the behavior of a plasma. So I'm interested to see how your brass works, how your voltage works, how you're using a double core, how one core goes fast, one goes slow, if the current allows change of the speed. These are interesting things to watch. But my advice to you is, once you set up your reactors and you set a voltage, take your time. Take your time. Don't change the voltage and expect the reaction. Don't change the current and expect the reaction. Go for a coffee. We run reactors for days, we see nothing. And recently we did something like a week run test 2-3 months ago. And in running the test, I knew I set the system up, but I had to be patient. And I went, next day I came. Every day, we increased the weight of the system by 20 grams. And after about a week, we were just about 100, 140, 120 grams heavier than when we started. We announced it, that we set the system to increase weight. Because if you sit there and you try to understand, you have to allow fields to lose enough energy to convert to mass that they have an inertia and they can interact with their inertia with the magnetic gravitational field of the Earth to show themselves as change of mass, as material. Fields do not have a measurable weight. Plasmas have a very small amount. But if you allow their fields, gravitational magnetic fields, in the interaction with each other or with the material of the core to slow down enough, they become mass. They become weight increase.
It doesn't matter. It doesn't mean a mass increase as in creating
weight
particles inside. It actually means to create more gravity or more
but you can do both. It could be both sides as well. But you can create conditions where your fields reverse and you increase gravitational field more than the magnetic field. But because of the material I put in the reactor, I knew is not a gravitational change. Gravitational weight is different than a mass weight. You see the weight, I'm getting feedback again. The gravitational, what I call the magnetic gravitational field of the sun scatters through the plasma of the solar system. We don't see it. It's part of the overall mass of the plasma. But if it reduces enough, at a certain point near the Earth, it showers back to Earth as a matter, as a weight, which gets added on to the weight of the Earth. You can set conditions to create that mass conversion to weight. There is a very fine point in understanding which one is which. I set the reactor for production of material, and I achieved by mass increase, by weight increase. You can set the reactor for gravitational magnetic field increase for going up or down. The point is, when we stopped the reactor, the weight stayed at the given weight. It did not drop. If when you stop your reactor and the weight of the reactor goes back to its original weight, then the weight increase has been due to gravitational magnetic field interaction.
But a scale would show either, so there's no other way to know if you're creating a field or creating
yes,
actual...
there is a way. There is a way to do it. The way to do it, you slightly change one parameter, and you see if the scale changes. If you change one parameter and there is no change in the scale, it means a weight conversion. It's a mass conversion. Do you understand?
Yeah.
When you change one of the parameters and your scale stays at the same weight, means you have converted to mass. This is a conversion of energy.
Sorry, when you're talking parameter, you're talking vacuum or ionization, that kind of parameter?
Not really. You can change the speed of rotation. You can do all sorts of things. You can change the speed of your motor to disturb the plasma. I do that quite a lot. When you disturb the plasma and you go back, you have to be very precise that you can go back to the value you preset, yeah, before you move. And you see the disturbance of plasma does not create a change in the mass, then you know you converted the energy to mass. This M is equal half, whatever you call it, the Einstein formula, which is the simplest version. But that's how fields or in motion convert and become masses to us. And you see it in your reactors. This is how we convert material in the reactors. The point is that, as you know, we have, started the institute. And we allow people to work and see this from on. They can experience it, they can explain it more in different language. I find out my language is very difficult for people to understand sometimes, but maybe in the future, the people who join us as part of the learning group, they will explain this in different way that you can understand. But you can check, you can see things, you can play with things. And you have to, the game of plasma at the room temperature, the way your systems will work and the systems we works, is time. This is not a tablet to take aspirin and the headache goes. You have to create the biggest point always put. You have to create the conditions.
Mr. Kesh, this is Lucian. I have a very quick question for you, because it appears that the gentlemen in this group, none of them were able to start up the device. In other words, to create a plasma condition. And based on your old lectures, it appears that none of us will be able to obtain nuclear material. And on the other hand, the nanomaterial, you are saying that you will coat with the new reactor. Probably at this point, you can only by yourself to produce it. So if I may ask you kindly to first explain to the gentleman how you really can create ionization without any kind of exotic materials, because in order to learn...
I don't know how to do it without exotic materials. You call it exotic materials, but these materials are part of our own structure. There is nothing exotic. If you read, I think...
I was speaking exotic about nuclear stuff.
What even now we see it can be done if you create the right condition. You can do it without the nuclear. You have to create a condition in your reactor that releases nuclear radiation at the strength at the level you want.
Right, but
Search,
up to now,
search, because up to now
the
we
gentlemen
don't
were
release. There are people who've done it without the nuclear material. There are some moves, some organizations who are trying it.
Right, but
in
looks
so
like the
many ways.
gentlemen in this group were able to obtain, the sphere, the ceiling.
But I think
how
this is
to
the
insert
whole.
gas.
This is the whole game. This is the whole game. Everybody does the way they think. Otherwise, we give a blueprint and everybody goes and copies. This is the essence of these workshops. These things. There are as many different ways to do it. As always said, the stars in the sky. I'm trying to cope with one non-nuclear system, and I had to choose this path because of where we are, and in a way, for a nuclear engineer like me, it's been a horrible time. It's just like cutting your legs and tell you to run. I build these systems around nuclear technology. I build these systems around how to use radioactive materials, and by forcing us to develop a new technology. It's like if you're a marathon runner and they chop your legs off and they say, go on, take a marathon. You have to find a way, like the other guys we see with the newest springs and new legs, how to run, and they still can run. This is a new direction for me, and this is I have to understand a lot of things. I walked away from experiment for nearly a month in past 6 weeks because a simple reason. Some of you know I had near cancer condition. And I had a cancer with the pancreas and liver 5 or 6 years ago. In being involved near these reactors, I start seeing changes in my body, and the warning lights came on. So it means I'm producing heavy radiation within the non-nuclear material, and I'm getting affected by it.
Right,
so
but what I'm trying to say is that probably in the next coming months, probably all the gentlemen in the group will be able to, start and rotate and fill the reactors. And if they cannot create the condition as you stated...
Well, we don't know. We don't know. We do not know. That's why we're running workshops. That's everybody's developing things. If you don't reach, sit down and think, why not? Go back to your own body. Go back into the physics of the cosmos.
I'd like to interject something here, Mr. Kesh. If you look at the thing that I just uploaded, the Hawksby generator picture, this is the very first electrical generating device ever.
I don't see.
Maybe it's just coming through, or
I have no movement on my.
Nothing on your thing there?
Okay.
It should be underneath the 5 files. There should be a...
Okay, I've seen it. It's getting loaded.
All right. And it's extremely... I just discovered this a few days ago, and I'm extremely fascinated because this is the original device that was used to first generate power, electricity. And it was a turning glass globe is what they used. And they put their hands close to or on it while it was rotating. at about, I figure, somewhere less than maybe 1,000 RPM, somewhere between 500 and 1,000 RPM, this thing's rotating. They put their hands close to or on it, and this globe glows.
Under vacuum condition.
So, pardon me?
Under vacuum condition, it's been vacuumed.
It'll glow without a vacuum condition as well, but it glows best under a vacuum. They didn't have high vacuum then. In fact, it won't work under high vacuum because there's no particles in there to cause the effect. But it causes ionization of the nitrogen and other gases inside the atmosphere. They also used mercury inside, and that was effective as well. That's how they originally discovered this effect. People are running around with a mercury barometer, and when it was jiggling the mercury in this sort of vacuum that's caused in the tube, it created glow, sparks and glow happening. So this fellow figured out a way to, he worked with Newton, Isaac Newton actually, and he was the guy who built the equipment for Newton. And he figured out a way of rotating this glass globe. You hold your hands close to or on it, and your hands act as a capacitor in such a way that it generates an actual, it's basically a plasma glow inside this globe. And it was such a novelty that they basically made it into street theater, and people were doing it as a novelty and getting, paid for people to watch it and this kind of thing. They didn't know what to do with it at the time. It took a while before they figured out how to make a Leyden jar and actually store the electricity in something. It could only generate in that moment, basically. It wasn't self-sustaining as such. But they found amazing things to do that you can charge up a Leyden jar enough to get a really good spark out of it and so on with this very, very simple apparatus. That was 300 years ago. And I'm going,
you haven't gone very far, huh?
For almost a year trying to figure out how to spin a globe properly and get it to, this plasma thing and so on. And these people were doing it 300 years ago and got a globe, a glass globe to glow without even, in a very, very simple way. And I'm thinking, well, if the plasma can be ionized that easily, then the ionization of it is not really the issue. It's more of the continuation of the process and to perhaps ionize to a higher level or
yeah, the whole game here is not ionization. Ionization is very easy to achieve. Right. In being able to merge the plasmas which you ionize together as one mass, as one field. This is what I cannot. I try to explain. The guy told me yesterday he used to work in CERN as a physicist. This brought me a lot of jokes back up. You know the ring in the CERN, the accelerator they have.
Mm-hmm. You
get higher speed in your reactors once you receive plasma in your little reactors. That's what they achieve in CERN, especially if you have a double core. You create a condition in your cores. It's very much like adding the gases of different balloons to one balloon. They're all in it, but as one unit. You create a condition that not individual plasmas are within the core. You create a condition that is amalgamation, is a collection of all the plasmas which you have ionized. As I told you, you reach ionization. Now you have to go to the next step to opening the plasma. Opening the plasma has several different ways of advantages. You can increase, you can work. For different works, you want the fields, you want gravity, you want to create mass, you want to speed increase of mass. You you ionize. What's the next step? You have to go to the next. Now this is the difference between what you showed us and where we are. Now we're going inside the glass jar. We're going inside what is in and how we can put them together. The reason I said this to you before, when you start running these reactors, when you achieve a plasma condition, don't add more material to the core. Take out very, 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 very little amounts of, or create a further vacuum while your plasma is running. You take the pressure off the plasma and the plasma opens up. It's like a sponge cake. It rises, it opens up. You let it run for 2 or 3 hours. You let it run for a bit. You think you created the plasma. Don't start playing with it. Reverse the vacuum system that you suck a little bit more, but don't release it into your vacuum system. It will control it that extra bit, whatever you take out, is connected to your exhaust system, that it gets into your waste tank. Because if you release that little bit of plasma which you take out of the reactor, it's so powerful that your auxiliary systems, like your vacuum pump on the end, they just melt. You find out there is something wrong with my pump. No, darling, what you've done, you release the energy which is contained in that plasma into your chips or into your plastic in your motor or in your vacuum pump. And that energy is so much that it burns your circuitry. The circuits just literally don't work. You find, oh, what's wrong? You take it and they tell you such and such a circuit has been damaged. You damaged it because you allowed that going. So when you achieve plasma and you want to achieve very powerful plasmas, you don't add more gases. You very fine, you have to put a valve. You see it in my people who've been into my lab, they see it. We build a 5 centimeter tube, and we create a total vacuum in all the tubes to the reactor, and we close everything, and we open the space into this channel, into this little tube. So we suck out of the reactor some whatever could be residual gases or whatever, or part of the plasma. These are highly charged. You close it, you close all your pipelines into the exhaust, and you release this very little amounts, it's so tiny, into exhaust, into atmosphere, through a filter. If you don't do, and you leave it in there, when you go to vacuum, it reverts back. I have burned circuitry of huge vacuum pumps by this mistake. Then you understand what energy sits in your plasma.
What type of filter do you use? What type of filter would you use?
I use usually a carbon filter, but I usually release it into a waste tank first, and then I release it into a water. I built a water filter where the pump goes into a water filter, and there is a water pump, and then I release it into atmosphere, whatever comes in. It's a very powerful energy which you take out of the reactor. You have, and I said this before, you play with your vacuum like your accordion. That's what I said before, a few minutes earlier on. You change the voltage and the current on your north and south cores, and then you will see it. So you have to understand what you're doing. And on the other hand, as I said, I'm a student like you, but what you tell me, I look at a different way than you do, because I understand a slightly different direction of the position of the plasma. A lot of people are creating plasma systems. A lot of people have no nuclear material. Just go back and look how the universe creates nuclear radiation. I was forced to, I knew about it. It's in the patent written 10 years ago. But I went and I had to go and re-educate myself and look at the situations. There are no radioactive material in the upper atmosphere. How does the radiation, we knew it, but how can we create the same condition? You can do it through gases. You can do it through solid material. You can do it through nuclear material. Just, I said this before, look at the upper atmosphere. How come you just talk and you just go? But don't go, stand still, wait, think what you said, what you read, what does it mean? How can nitrogen create extreme ultraviolet in the upper atmosphere? Create X-ray in upper atmosphere, which leads
But
to
Mr. Kesh,
conversion.
one second, please.
Yeah.
This is based on what regular people are knowing, right? From whatever you call chemistry, is that the electromagnetic radiation, right, is hitting the nitrogen atom, and based on what spectroscopy says today, once the atom is excited,
Wait.
emitting photons of specific wavelength. This is what we know. So if we are wrong, please correct us.
Yeah, the thing is, what we call the quartz stones. We squeeze and releases energy.
Yes.
Yeah.
Is a piezo.
The same thing.
electric
The same
phenomenon.
thing. Yeah. The same thing happens in the upper atmosphere. They say electromagnetic wave hits it and it leads to release of what they call soft X-ray. But in fact, in reality, what we've seen and what we created, this I explained if you listen to the other lectures we had or the workshops. This release comes because of the magnetic gravitational field pressure from the Earth, which continuously changes in conjunction with the magnetic field pressure from outside. If the field just hits it, chemists try to explain it that way. But in reality, to me, as a physicist, doesn't happen. You cannot release something just because of what they say. We accepted a lot of rubbish. You look at it. You got a quartz stone.
I 100% agree with you that probably they are wrong, but my question is very, technical. So we have the nitrogen in the upper atmosphere, right, which is in the magnetic field of the Earth, as you explained, and it's hit from the outside, from the sun, by electromagnetic radiation of specific, frequency. They say so, or magnetic field strength, as you said.
Yeah.
So now this nitrogen atom probably is accumulating this radiation, to name it, or magnetic field.
That it releases the.
No, I'm saying first it's accumulating, right? It's receiving energy.
Okay. No,
so
let me explain to you. Okay, let me explain to you something else.
Yes.
In our reactors, in our patents, we speak about multi-layer gassing. Nitrogen, if it's on the outer layer, is the last layer, you'll find in creating the condition. If you put argon and then nitrogen, then you have the effect of what you call outside magnetic fields, because argon allows that cushioning and the release of the fields which you need to ionize the nitrogen. This is the technicality. If you have a copper core or you have a brass core, which is the material, this is why we suggested use multi-gas cores. Layering is not just the insulation. Layering allows what I call the accordion effect. Then what you get from the magnetic field of the sun to put pressure on nitrogen to release the radiation, when you have an argon or you have another material or gas which behaves the same thing on the other side, then the nitrogen is squeezed in between and it does the same job. I tell you, don't read and just go. Understand why. Why do you put layers and layers? Why? Even if you use 3 gases like hydrogen, nitrogen, and helium, helium releases extreme ultraviolet much easier than nitrogen. But the nitrogen becomes the layer which allows the pressure of the hydrogen to push and for helium to release its extreme ultraviolet. Understand, you just read and you think this is what's got to be done. Understand the process. In the body, in the human body, most of the extreme ultraviolets, when there is no nitrogen, is done by the conversion of the oxygen, which goes to nitrogen. Nitrogen is too high to release it, but the helium which you released creates and releases the extreme ultraviolet. I've tested this. It works beautifully. You don't need a high temperature. This is how your lungs work. This is how you go from from oxygen to carbon. And then you say you breathe out CO2. CO2 comes through the blood. A lot of nonsense. That helium which is released, it creates, it's in the paper I've written. If you read the CO2 paper, I've explained this in the paper which is coming out about the function of the lung and blood. I gave this lecture in Bulgaria and I spoke about it in Belgium in the lecture.
Right, I think that this was understood, but what is not understood is while we cannot create the structure, I mean, of the lung, what kind of material
you have it. You have the nitrogen, you have an argon, or you use nitrogen, helium, and oxygen. What else you want? You have everything. You have everything in your hand. You have to understand how to operate it. And people come with the nitrogen and they want to do it. No, maybe it's done. That's why I'm watching. That's why we're all learning.
So to answer to your question, and please correct me if I'm wrong, what the mainstream physics says about, to answer to your question, how these magnetic fields are created in gaseous planets is because of the rotation of various layers of gases with the specific omega fields, angular speed. Because of the friction of these gases, these magnetic fields are created between the layers, and this is how this ionization is created. So I don't know if you agree with this or the theory is not good.
To me, it's a lot of nonsense. To me, this is a lot of nonsense. Because you go back to the you have different layer of gases. You go to the center of the stars. Where are the gases? In center of the stars, different magnetic field strength plasmas, they create the layering. Do you understand?
Right, so going to our, let's say, our reactor, it's filled by specific ratios of gases, as you did explain, with purging, vacuuming.
The ratio of the gases you fill in reactors is on what you expect to be your production of radioactive material or radiation material. Because at the end of the day, everything else, the whole of operation of creating gravitational magnetic field is decided by the plasma which comes from hydrogen, ionization of the hydrogen. So that does not make any difference. You can't get a plasma out of nitrogen or helium.
Right. So my next question will be this. Based on the current science, one can calculate one single atom of hydrogen how much energy has, because you can make an equilibrium between the
If you have found out, and if the world scientists have managed to find out how much energy is inside of one plasma of hydrogen, we have cracked the whole world of the science, and I don't think we are there. This is what we wanted to accept. In the energy, I've talked about this, energy in the plasma, a single plasma, is enough is enough to give food, energy, and all your needs for at least about 10 generations.
Yes, I've
So we
heard your
cannot
previous
put-
lectures, but my point is this: once you start up fill up the reactor,
Yeah.
right? You have to know, for example, how many atoms of hydrogen do you put in to achieve starting condition. It's my feeling, and the gentleman in the group could confirm or not, that at this point people are vacuuming, they are purging, are filling some hydrogen there, are filling some whatever argon. They start to. I've seen the ranked
Yeah.
video he posted with his colleagues in Holland, and they
Yeah.
started to rotate the device, and they achieved nothing. So basically, now if we do not have the knowledge to understand how to say what is wrong, I mean, what have to
Yeah,
be
yeah,
done.
but the thing, hold on.
Yes.
We don't have a patience, though.
But
No,
knowledge.
no. You've done everything right. You do everything right. But a lot of you got to, because you have first of all, you have two problems. If you have a double core as multi-core, more or less, most of the reaction you get is from your inner core, not from your outer core, because you have not managed to isolate your outer core, outside surface, which is inside the bigger core. So whatever effects you see, if you put multi-gases layering inside it, is from your small inner core. Because from there on, your outer core and inner core are connected to each other, so you don't see anything. This is fallacy. Because outside your inner core, no, but I have developed a material to create that insulation at the moment. So we're gonna step further. So our reactors, our cores are totally separated. Totally separated. We know, we tested, there is no current connection. Doesn't matter what we do with it. I've developed it to be that way. So I had to produce material that way. So first of all, even in your small inner core or in your single core, if you put 5 gram or let's say 10 gram or 1 gram of hydrogen, the first feeds of hydrogen immediately goes wasted. Their first plasmas just disappeared because of, how can I say? Because of the absorption and losses in the blood walls, yeah.
Right.
So you lose parts, you put in and you see no results, because you have to understand you have a continuous loss.
That's correct.
But you have to create continuously ionized plasma. You have to create a ratio of conversion faster than your loss. You have probes. All these probes you put in the reactors, these are recipe for disasters, recipe for loss of plasma. You can go in, you can put a probe. When your probe is totally, absolutely insulated from the plasma, and plasma never comes in touch with it. It's taken me 30 years to develop this technique.
Right, but for the gentlemen in the group, I've seen that most of them, they have a single core reactors, as Rank, Ludmil, and so coming to your example, they introduce hydrogen into the core.
First of all, you introduce the right amount of your gas layers,
right,
of the ratio. And then when it comes to your hydrogen, you reduce very, very small drops. Very, very small drops. Very, very, very minute amount. Minute amount. Not the same, you take the ratio, that much gas, that much hydrogen. Yeah? Right. But you introduce that ratio, it's like, when you make, let's say when you make mayonnaise, huh? You choose, you're gonna make mayonnaise with 0.5 liter of olive oil, yeah? You don't put all of it in with the egg in one go because you chose that much. You choose and you drop in. You drop, a very small drops at the beginning. This is how you build up your plasma. Just 1 second, please.
Now, Foth will want to get in here soon as well. I think.
So, Lyudmil, I will continue with this because I started to do that software a little bit. And the idea will be, if what Mr. K said, that we have a very small tube of 5 centimeters or whatever, 1 centimeter, 5 millimeters. So we can introduce in the vacuum very, very small amounts of hydrogen while the single core is rotating, what Rank did in that video with his colleagues in Holland. So what I'm trying to figure out, if this is the path, in other words, you rotate it, you see what's happening, you put a little, I don't know, maybe another 5,000 molecules of hydrogen and so on, to see if this would be the path of, you know,
this is your
going
correct.
to start up.
You're correct.
Oh, okay, you're back.
Yeah, I was listening to your explanation. I'm a student, I'm a knowledge seeker, so I learn from you.
So basically, Mr. Cash, I can do some software, right? So the idea is to automatically compute the gentleman's volume of the sphere, have some standard tubes, as you suggested, like 1 millimeter, 510, 1 centimeter of copper tube, whatever. And after that, this could be filled with hydrogen at specific pressure. So that will calculate based on the temperature in the laboratory how many molecules will be, and you can release it in incremental values, to speak so.
That's how it should be.
They have
so you are trying to suggest that once you start putting very small amounts of hydrogen at a specific point, the plasma inside the single core reactor, I'm speaking about only about this.
Yeah, you're correct. You build your plasma up.
Yeah.
Because realize something very, very simple. Go back to what we talked about all the time. When you create a high vacuum pressure, even if you have a small vacuum, yeah, the gases work heavy outside and light inside. Is opposite to it's very much like a centrifuge. And now you have a centrifuge and a vacuum together. So you re-emphasize the forces. So when you put in a small amount of hydrogen into your core in drops, the hydrogen doesn't go untouched to go inside to the center. The hydrogen sits between the plasma and, let's say, nitrogen or helium, because it has a different mass. So at that layer, it's lighter than helium, but it's heavier than the plasma. So you create a layer of hydrogen between the plasma and the nitrogen or helium. And now this layer is releasing extreme ultraviolet into the hydrogen, ionizing the hydrogen, opening the plasma, and adding to the center mass of the plasma.
So you are trying to suggest that the hydrogen layer, which is the getting continuous energy from the plasma to split.
No. Doesn't get a continuous energy. It gets continuously ionized.
Ionized, okay, gotcha.
Ionized. And in ionization, you'll find out your electrons, the motion of the electrons will go to the center of plasma. You have a double layer plasma. This is something which has to be explained. My belief is when you create a plasma, two things happens. You add the mass or the fields of the proton into the center plasma, Or there is a possibility, this is debatable, but in one way it's correct, in one way it's not correct. In the future, when we have more advanced system, maybe we can answer this. The plasma of the electrons which are created due to ionization, where do they go? My assumption, because of their size and their weight and their condition, they become the lower layer to the main plasma inside, in the center. But would they open up in the transition point from one point to another and become part of the main plasma? We have a homogeneous plasma which is made of both from the fields of the electron and the proton. This is debatable. I think it's correct, but on the other hand, you have to always keep your eyes open, and then you see different characteristics of the plasma behavior when you get a full ionization without gases.
This is suggesting me a path of going on this. You had a paper stating something about the electric fields. So if I have a way to inject energy into the reactor, right, without current, without electric current. So now, if you allow me a joke, I will come to the rubbish I was talking about, the old-fashioned plasma, the cold plasma. So usually, because of high voltage between two electrodes, is a current that is established between the electrodes, probably will defeat the purpose. But if I have a way of establishing the electric field without current, and this can be done with electronics, that means that makes sense for you?
But electric is a magnetic source.
We are now, it is the same, you're correct. In a way, it's fields. You answer yourself back. Can I ask you one question? Where are you from? Where are you? Which country you're in?
I am now in the United States, but I'm from Romania, near Lyudmila.
Ah, okay. What do you call it? In a way, you're right. But as our other colleague said, this is a magnetic field. Energy is magnetic field. So if you can find a way inside the plasma to release this field, what you're trying to do from outside, it'll be more natural and you have more control. You're both correct. You're correct.
So in other words, let me put it this way. Maybe you could, maybe you have more scientific papers than me. You have two electrodes at the high voltage, right? Speaking, let's say 20 kilovolts and up.
Yeah.
And I have a way, as I said, not to have current. That means from one electrode, I will have positive ionized electrons. So I'm speaking probably about spin rotation of, and from one other, the positive electrode, I will have electrons positive, polarized, which probably is having the same charge, but sign. Probably the spin is different. So now at this point, as the two, technically speaking, the field will neutralize themselves as, as you explained with the plasma, as a global charge. That means, and this is the question I want to ask you, that means I do introduce mass into the reactor because as the electrons have a very small mass, they still have a mass. And if so, I have to some sort, it will influence the plasma, and do I need to suck some mass out, or being
I don't know. You see, there are two ways to look at it.
Right.
Do you release the energy of the vibration of the electron, or do you release the electron into the core?
Well, it's a very good question.
Yeah, because to me, you are releasing the energy of the vibration, not the electron, that it becomes mass. There is there is a fundamental point. If it's, I don't think your theory stands or your
So let
assumption.
me ask you a quick question, because
Let me just ask you. Let me answer you one thing. If you use an electron gun and shoot electron directly into it, your assumption could be right. But if you're sending a charge, positive, negative, you are releasing the vibration fields, or what I call the vibration of the electron. You're not actually releasing electron into the plasma or into the core. There's a big difference.
So it appears to me that you did study this X-ray system, I mean medical. So the question will be this: if on a regular CRT tube of TV, right, instead of having a filament which is heated of tungsten, that will emit flux of electron, as you said, I am putting just like a sharp needle to throw charge, not the electron by itself. This makes sense for you? I think I am releasing only the charge, not the electron.
No, the electron. If you release the electron, yes. But if you release the charge, I don't think so. But in any way, at the end of the day, these charges, if they are in the right length, they become part of the mass anyway.
Okay, so we'll increase the mass, the material, as you are saying, into the reactor.
We got to learn something very simple, and this is part of the problem, which has to be understood. And when you understand it, it becomes a walk in the park, as they say. The energy inside a proton, single proton, it is so much. It lasts for millions and millions and billions of years, because otherwise it won't be there, we won't see it. If you manage to use the motion of these fields, because it radiates out, the field from the principal matter radiates out equally, more or less. If you can manage to use different position layers of this plasma of a proton, you will have everything you need. On the edge, where it becomes tangible, where we see it as a proton, this is where you get your matter.
Right. So,
somewhere from that edge, somewhere from that point of matter to the center, to the principal matter, you have different strength. You have a radiation section, you have a gas section, you have what we call transition matter, and each one of them have a different energy strength. Do you want a kilowatt? Do you want a watt? Open your eyes into reality, then you see your core is the same as a single proton.
Right. So based on what you said, I see here two paths of achieving technologically the ionization. Is one either to have some electrodes, like cover maybe with carbon, stuff like that, and as you explained in the previous workshops, to be tangents to the sphere, not to protrude into the inner layers. And with old-fashioned physics calculation, one should take care not to release electrons, I mean physically, to inject mass. Or two, having a reactor core, as you suggested, from plastic, and having a rotating magnetic field, like in a regular motor, which would interact with the gases inside the plastic core to rotate them. Does this make any sense for you?
I don't understand.
I can answer that. I can actually on my video roughly what we're talking about.
Can you repeat
you
what
have,
you just
like,
said?
outside the plastic core on the disc.
Yeah.
So let's say you have a plastic disc, a flat one, with let's say 3 magnets at 120 degrees, and that are rotated outside the reactor.
How about 6 magnets at 60 degrees instead?
Right.
That's what I have here. And it's a rotating disc underneath the whole reactor. And I have tried creating a plasma inside, and then, the high voltage plasma, like I do, and rotating the magnets to see what will happen, to see if it would stir it up, like you're discussing, right? And
right, but not inside.
Eh?
It's not
On the
inside.
outside.
You do the magnets
They're
outside.
not-
I've
not
done this.
inside. The magnets outside. The magnets
uh,
outside the chamber totally. They're underneath the chamber, but they're high.
No, let me
It
explain to
doesn't
you
do
something.
anything. It doesn't do anything to the plasma.
Yes, it does.
It
It does. Rick, it does.
Well,
When you have a when you have a plasma, because I've done this. If you come to the lab, people will see. I have built units with plastic screws, and I've created a specific with different magnets, different conditions, and I have like exactly like yours, 4 poles, and I can adjust these magnets, these sets, in different position. And yes, it does. It really affects the shape of the plasma inside the reactor. So it has a direct interference with it. And I have, I think, about 12 units. And I wanted to be that there is no connection to anything else. We made what do you call it, transparent plastic. We placed these in. We have screwed it with plastic. It's all secured to the metal frame with plastic. There is no connection, and we run a reactor in the center. And it does have a direct effect on the plasma and the way the plasma behaves. Even in some cases, with the reason we did it was before or this was done after I came back from Tehran, because we could see the effect of the plasma cores next to each other, how they could interfere. And I did this to see if the solid magnets have the same kind of effects into the plasma. We know it does, we've seen it, but the way we can dictate the change of the gravitational magnetic field and weight of the system, it has a direct effect. It creates a friction between the fields. But then I ran a test in changing the strength in the core, because the magnetic field outside was fixed. We couldn't change it. They were solid magnets. And you'll find out the friction between the fields does affect the creation of the plasma and maintaining the plasma.
But if you can move that magnets closer and further, I think it will affect too.
Yes, we've done that. You'll be amazed how many experiments I've done. Yes, you can do that. You can do that. But it has. You can do different things. You don't need to bring it closer or further. You just use different strength magnets. It gives the same effect. But the point is sitting there. Something which I have and most of you don't have, I hope you will see it. As I said this before, I managed to get a specific field detection system built for my work in Switzerland. And this system gives me a full 3-dimension of the motion of all the fields in any matter. So you see when you put magnets in respect to the core, you see which way, if it's positive, is negative, if the fields are coming from the poles of the reactor, or the fields are coming from inside the reactor. Because there is a concept at the moment, which a lot of scientists talk about this nonsense, that on the equator, there is a different field, is zero on the rest of it. This is all nonsense. But with this reactor, with this system, you can see it. So I measure, because the electrode does not move, sits in between. I see the direction of the motion, which way the fields are coming in 3 dimensions. If the field is coming from the core, if the field is coming from the magnet, or if the field is coming from the poles of the core. If it's tangent, what do you call it, in tangent with the center, we feel 3, because we have 3 detectors on the tip of this detector. And we see positive, negative, if it's absorbing or releasing, or which game is played by which fields. This gives you totally different insight. And then you see if it's in, if your weight goes up or your field moves to one side. These are the facilities which, when you do research, you need than guessing. And then you have a detect. Yeah.
You increase the mass with different gas molecule weight, correct? Let's say if you want to increase the mass. Let's say if you want to increase the mass of plasma, so you can increase it with hydrogen, increase it with helium, you can increase it with argon. So it's a different atomic weight you're adding to the core.
Well, you don't work that way. When you start your reactor multi-layering, your heavier gases, once you start the reactor, are not touched anymore because you have no need to do it. Why should you increase the weight? Once you introduce your, let's say, outer layer, the heavy gas first, and then the second or the third one, which are the layering, you don't need to increase. You don't need to touch it until the end of stop the reactor. They stay there. They have no use. They're just a blanketing. I use the word of blanketing quite a lot in my work.
Ratio, correct?
Pardon?
You have a ratio. Okay, let's say if you are releasing 3 or 4 gas mixture, you have a ratio. Let's say this much.
The ratio, you see, the ratio is how thick you want your blanket to be and how small you want to make your plasma.
Okay.
Yeah, you put a thick winter coat on, then you have less room to walk, to move in, or you put a thick coat on.
Okay.
Yeah, so the size of your reactor core is dictated by physicality of your core.
I'm talking about only one core.
Yeah, in one core, you're physically restricted by the diameter of the core.
Core, correct.
So, if you want a very small plasma in the center, you increase the ratio of the gases of your blanketing.
Okay, I got it. Thank you.
That's all it is. So if you want to work, I think it's better to work with a higher ratio of the gases to start with a small plasma. And as I told you before, start withdrawing the gases, start withdrawing a small amount, then you allow the plasma to open up. Then you see the beauty of creation.
But Mr. Kesh, this is suggesting me a way of doing reactors at atmospheric pressures.
That's
like
what
this.
I know. Yeah.
Just a second. You have let's say your core, your sphere, whatever cylinder, what you have, and you fill it, for example, with vegetable oil, and you seal it. On the recipient, you have a one-way valve that whenever the pressure is increasing into the recipient, it's going to get that pressure out, but will not suck air from the atmosphere at all. So now, if you create an old-fashioned plasma, I mean cold plasma, the rubbish you are saying, and you will transform that liquid, the vegetable oil, and I did this, is working. I mean, I did this, is working in the old-fashioned physics. You transform the vegetable oil into gas, whatever that gas is, CH4, hydrogen, whatever, a mixture. And some carbon is deposited on the electrodes. Obviously, based on the gas law, the pressure is increasing into the recipient. That one-way valve will release the pressure into atmosphere. So technically, you start to somehow probably have a quite smaller pressure than the atmospheric pressure. So do you think that this is going to work or could be a path?
I love to work with you. I would love to see how you do it. I can understand liquid reactors, but it's nice to see how it works. This will be very interesting. What do you do? Because with a vegetable oil, you have the hydrogen as part of the, what do you call it? The chain reaction.
That's correct.
As part of the chemical. So what do? You are creating a condition of releasing the hydrogen. The whole game is to release
But
a
it's
proton.
releasing not only hydrogen, but let's say methane and CO2 or whatever, any other gases.
But the thing
You'll have
is,
vapor
then
pressure.
you have, because you're in atmospheric condition, you have your hydrogen in the outer layer of your bubble, and CO2 in the center. It works opposite.
Okay.
In a vacuum and a centrifuge, the heavier you are, the further out you go. That's why it is that way. If you don't have a centrifuge, you create a high vacuum, so you get the heavier out to in. When you don't have a vacuum, you create a centrifuge, you achieve the same. The heavier matters go outwards. When you mix vacuum and the centrifuge, that's what you do, that's what our friends in Malta are doing. Then you create a very strong vibration field inside the reactor. But in your case, it's totally opposite. You're working in the atmospheric pressure, so your hydrogen sits in a tiny layer between the liquid and your gas in your bubble.
Right, on the top, right.
On the top end. So now you try to ionize that. You try to ionize that hydrogen.
Okay, so supposing I can do that, the plasma should glow on the top of the cylinder, to speak so, if it is a cylindrical.
Yes. But
So
again, you
technically,
can do this. Technically, actually not technically, a lot of planets work that way, the way you were working. A lot of planets work, but the tip or the point or what you got to look for, you have to create a layer in your tube or wherever this gas come in touch with, that it can give you what you want as a gravitational field. We have liquid planets. Liquid planets work in that way. But then you go into the gas.
Specifically, what should I do? To rotate the tube or what?
I think the rotation is part of the essential line of gravity and magnetic field. This is a difference between the inertia and gravity. And inertia is created by the atomic structure. Gravity is created by the dynamic structure.
Right.
So you have to find out which way you want to do and which way you're doing it. We have an inertia, our body has an inertia because we cannot rotate, otherwise we'll become like a frisbee. So
right.
within
So
the
basically,
containment to do it.
In the reactor I was suggesting to you, one of the electrodes is like a chrome mesh. So let's say maybe after 5 minutes, that chrome mesh is covered with carbon. So probably I'm assuming that will be an insulator between the metal and the plasma. So it will not kill it.
It could be a conductor. It could
That's
be.
correct.
You gotta test it. It's just test it. Test it. You could be right. Test it.
And if it's conductor, probably
I
should
tell you. Yeah. Let me explain to you something very easy.
Right.
One of the problems which scientists, researchers like all of us in this forum has, is we don't have access to edge of science equipment to find out what we produce.
Right, they're very expensive.
Yeah, very expensive. And then when you take your material to the people who have the materials to test it or equipment, they try to steal it from you. How
yes,
you do
that's true.
No. This is Keshe Foundation, me personally, and our team. One of the biggest problem Keshe Foundation found, and we became on exile from Belgium, was doing exactly what you told me just now, what you said. We became, do you know the Keshe Foundation website at the moment is down? We're deliberately keeping it down because after the peace talk on Sunday, and I put an article on, we came under such a heavy attack that the server room with all the 24 servers in the rack were blown up. They made sure we don't come. But hold on. Let me explain this to you. No, you have to understand where your problem sits.
Okay.
We, years ago, in 2004, 2005 did exactly what you told us, just what you mentioned. You create carbon. You don't know if it's an insulator, if you don't know if it's a conductor, what carbon it is.
Right.
A gentleman who is close to the royal family of Belgium, who helped us a lot, or we think he's close to he's close to the structure. He said to me, give me one of your electrodes. I want to test it. This electrode was taken to a company called IMEC, IMECU. You read it. It's the biggest nano organization in Europe at the moment. They took this electrode to be tested. Those days I was green. I was a man who came from business into science full time, so I trusted the way we used to work in our business community. We trusted. Our word was our bond. So this gentleman, he's very nice. He's helped us quite a lot in the foundation. I gave him the electrode to see what this electrode is, because they came to see the first bottle in a hotel in central Brussels. Ricky can ask Dirk, he was there. And the guy wanted to take pictures from this cocoa. He says, this is impossible, creating plasma out of nowhere. But this electrode, I knew, is a nanomaterial and what it is, but nobody else knew. So he took the electrode to be tested by IMEC. Then we tried to get hold of the report of this. What is this material? They would not give it to us. No, we done the test, is ours. I said, you took my material to test, and now it's yours because you were supposed to tell us. Dirk can tell you, what do you call Declorescence, who is the main, people in the Keshe Foundation structure. He was all the time with us. We asked for this report back. In any way, I managed to get a copy of the report, and we had to negotiate with IMEC. And if you go in the old website of the Keshe Foundation, you see a graph which says this is SP3. In that report,
right, that is on some of the papers.
Yeah. So in that report, IMEC found out that we are producing SP3 at room temperature, which is impossible. So they wanted to keep it a secret.
Right.
Like
so coming back to...
we took the wait. I have to tell you this. It's important. And in finding this material, finding that how we produce nanomaterial at room temperature, we produce SP3 at room temperature in a different way. This became the death nail in the coffin of the Keshe Foundation. They tried to steal. We tried to keep it open, and that from that point between the lawyers of IMEC and Keshe Foundation has led to us to come on exile into Italy with a simple not knowing what the material is and what they found out. And in the report says there is a SP3. Yeah. So if your problem and our problem with the way we work, we don't have access to a lot of testing equipment. And it's all guesswork if it's a carbon or if it's a conductor or a resistor. Over the years, not to rely on these people again to run to this problem, which has been a 10-year problem with us, with the Belgian authorities, is to find a simpler way to do the testing yourself. There are different ways. If you find, good morning. If you find a material, you don't know what it is, and you cannot find the characters, you can test it, you can become alchemy and twist it to see if it's a carbon, if it's not. Find a way, a simple ways which happens in the nature to find out what you produce. Nanomaterials do not dissolve in acid. Nanomaterials do not dissolve in alcohol. Nanomaterials do not behave as a conductor in certain direction and ways. Yeah? So you have to find out. I learned this by actually taking some of the nanomaterials I produce, and I took the acids from the car battery, and I tried to dissolve it. It doesn't dissolve. I couldn't understand at that time why. The knowledge I read so many lectures, so many literatures. Good morning, Gordon. In so many papers about new material, what nano. We knew all these years ago. It's in the patent. They are taking the
Got
patent.
your point.
So,
This can be done with small resources. To
the
see if
small
it is soluble in
resources,
acids.
yeah. If it's insoluble, if you create a nanomaterial, if it's a carbon, yeah, it shows a reaction. If you have a plate, if you have an electrode which is coated with a black material and you think it's carbon, yeah, do very, very small test. If you don't understand it, just go to the best friend on this planet for scientists. It's called Google. Type in your thoughts. Nothing else. Just type in your thoughts. And then you see if there is anything in the world, research done, it'll come up. And then you see you're correct or not, or you're in the right path, or you can define a new thing.
Got your point, you're right.
So go. You made the black material in your tube. You keep on talking about the black material. I ask you what you say you don't know. If it's copper, if it is what do you call it, if it's a carbon, if it's a nanomaterial. Simple test. Go to your car, take an acid. Car acid is one of the best testers.
Right.
Then take alcohol and take a mixture of alcohol and carbon. And just test it, and then you know, yes, this is what it is. And you read the properties of nanomaterials in the structure. They cannot be separated with acid. There are millions of scientists researching in the world, so you know what your material is. Wait, no. This is not chemistry.
Well,
this
sort
is physics.
Of the matter, correct?
Physics.
Pardon?
So coming back to the reactor, Mr. Cash.
Start of the matter.
Go ahead.
So I will finish so to leave the other gentleman to put other questions.
No. He's trying to tell us something.
Oh, okay.
Then we carry on. Hello, what do you say about nanomaterial?
It's a start of matter, correct?
Not really. It's a different structure of matter. It's a different structure, but it's still matter.
It's not matter building on it, like it's a fields, like it's a first structure, it's a nanomaterial, then it grows up.
Not really, no. That's a myth in the world of physics as well. Nanomaterials are different structure, but the same atom. It's this different structure, and then you have a sp3, which is the same thing.
If it's different structure, but it's a component of the structure.
Yes, but in different orientation, I should put it that way.
Okay.
The orientation of the element dictates what and how they behave. The same atom, if it's orientated in one direction, like in carbon, is a conductor. When you slightly change the orientation, crystal structure, it becomes a diamond.
Okay.
Yeah. And then if you change it slightly in a different way, it becomes a smell, odor. You understand? So it's the same. It's an orientation of the change of the atom, how they lock into each other. If it's locked in one way that it makes a neighborhood, you call it a nanolayer. It's been there from the beginning. If you read the people who got the Nobel Prize for nanotechnology in Manchester University a couple of years ago, they've been on our website like hawk, reading everything. And it's in the books and it's in the patents that the nanolayers are part of the inner structure of the Earth if it's got a solid state. So we knew nanolayering and conductivity, and what they claim they found out is in the books 2004 patents. So you have to understand the orientation. It's very simple. I said this before. The same gas is a gas, we don't see it. The same gas changes the orientation, we smell it. Yeah? And the same gas changes orientation in different conditions, it becomes GANs. But it's still the same electron and proton. orientation, and the level of the field strength.
When you say orientation, it's like a magnetic field orientation?
Orientation is it's very much how the electron rotates around its proton.
I was going to say electrons spin around the proton.
It's a gravity and magnetic field. It's
a distance. It's a distance, and the distance and the orientation of the rotation, and the speed of rotation of the electron around the proton. These dictates what is going to become. If the electron moves too far out from the proton, very far out, because of certain conditions created in the environment, this becomes order. If it's the same electron is brought in close to the proton,
meaning
this becomes
adding more heavier elements in the core.
No. I'm talking about the single atom.
Okay,
I'm talking about the single atom. If the electron moves too far from the proton, it becomes order. It becomes a gas order. If it's closer, it's a gas. If it becomes closer and closer, then it becomes matter, then becomes nanomaterial. Depends on the position, because it compacts. When it compacts, it becomes matter. Yeah? And then if it's the rotation of, it's the speed of rotation dictates how much electron, how much. This is exact. If it's too hard to understand.
No, it is.
No, just wait. This is we use the same property as creating electric current. The electric current is created by the motion vibration of the electron within a certain bandwidth.
Correct.
Yeah?
Yes.
So now take your knowledge a step further. Let this electron loose. Where is it going to go? How far is it going to go? If it goes too far, you get a plasma, you get ionization. But before it let go that the two forces are separate, you already reach a state of order. You understand? If you can smell it before, if you have a tool to smell, to absorb a smell, we smell the field before the electron separates from the proton.
Is there the reverse of that too? Can the electron go too far close to the proton?
Yes, it's in the paper. I've written it. It's called, and it's in one of the papers I think I've written, and it's in the back of the books. One of the papers I've written, they call it interatomic fusion. Interatomic fusion is when the electron is absorbed back into the proton, reversing the decay of neutron. It's the same process, and this fusion is much easier than releases much more energy than what they are trying to do as a fusion in bringing two protons together, because they are of the same source.
What condition allows the reverse of? I think of like this way: if you think of an electron and want to move it away, you can heat it, or you can add potential energy to it.
No, this way you play with the gravitational magnetic field of the environment. There is no heating, there is no pressure.
Right.
You play with the gravitational magnetic field. This is what I just said to Rick just a few seconds ago about putting magnets outside the core. You dictate the environmental pressure, magnetic field pressure. You don't need high temperatures. You don't need what you call cold fusion is a normal thing, happens in our lives, daily lives. But we made it because we don't understand it. We made it, is it possible? Is it a cold fusion? Cold fusion is process of your body every day, billions of times. That's how you get cancer. Cold fusion process is part of the cancer process. Yeah.
Before you continue, because I want to close my question, so I can leave you.
Carry on. Sorry about that.
No problem. Speaking about the liquid core reactor, so after, let's say, a couple of minutes in which the vegetable oil is transferred or transformed in gas, and we have the valve that will release the pressure, physical pressure of gases. And after that, to create the vacuum, I could have a pump on the bottom of the tube and extract liquid, because as the gases are going the upper part and I am extracting liquid, like having like a bottle and I'm getting liquid out from the bottom.
You're talking about the liquid vacuum system.
Right, so that should increase the room for the plasma as we explained in the previous lectures. So technically the reactor should start, or so. Success on that?
Yes, you can do.
So in other words, instead of having
so much vacuum out of it, because you'll have the vapor pressure of the oil in there to
right, but once I'm getting liquid out, that is going to ease the
yes,
pressure.
but the thing is,
pressure
you
builds
know,
up again, though.
I believe liquid reactors are an option in the future. They are an option. I love to do what I call liquid hydrogen.
No,
reactor.
I was referring strictly that in that tube the remaining vegetable oil, strictly material, is going to be extracted by a pump on the bottom. Physically, will taken out. So as the gases, as you said,
I understand.
hydrogen,
yeah, I understood clearly. But depends how much you can ionize. What can you ionize now you receive the hydrogen?
Right, supposing I can do that, but I was
don't suppose you can do that. I know you can do that.
Right, but you were saying you have to give room for expansion. So my idea was that
no. You don't need to give room for expansion. You create a condition. Actually, you reduce the environment. You reduce the environment pressure on your plasma to get you want out of it. You're looking in the wrong way or another way.
So you are saying that once the gases start to build, as I explained, the plasma, and if I can ionize, that means the reactor should start.
Ionization is opening the magnetic fields.
In a way, liquid which you use, it's a carbon hydrogen bond.
That's correct.
So you release the hydrogen, you absorb the carbon and the rest of it. But okay, now you got the hydrogen. What are you going to do with it next? You need the material to release nitrogen in the same core. You need some sort of helium you can produce or allow to be in there. Now you have your system. But all you've done...
But the helium could be injected as you explained in the past lectures. So
but the thing is, your process of the process you explained to us is you created a way to create hydrogen, atomic hydrogen or molecular hydrogen.
Right.
So now you're back in the same core. We don't need to be just buying a cylinder of gas and putting it in. You understand? Right. But you have one advantage point. I go back to what you said. Look at the structure you created.
So the point I'm trying to make is if I can ionize the hydrogen without nitrogen or helium.
You can't do it. You can't. There are two ways to do it. Then if you can find a way, yes. Then you have to make your gases or your plasma to rotate.
Gotcha.
You have to get it. You have to create magnetic rotation. You don't need to use pumps. You can create a magnetic rotation very easily with liquid reactors.
Right. Okay, so it looks good.
I think people in about 100 years understand what I just said.
I will keep you posted because it looks like it's a business plan. And I have one more personal question that probably will be interested for a lot of people. In Europe, at least, the old people are starting to develop like calcification of, like, say, ligaments and stuff like that. My mother is in the same position. So as you stated with that gentleman with ALS, one of these breathing devices you are doing could reverse this condition in the body and order to rebuild the cartilage on a knee, shoulder, whatever. Or it is not done?
Calcification, no, the calcification in the bone. Go and
No,
look
no,
at
in the cartilage between the bones, like
yeah. Go back. You have to understand the structure of the physicality of the body. Most of the calcification in the bones, or what we call even arthritis and the rest of it, comes through the operation of parothyroid glands in the body. What happens? Part of one of the, you know, what medical side. You have a thyroid glands which are under your throat. And these glands have 4 satellite subglands, which are outside, called parothyroid glands. There are a handful of scientists, specialists in the world, who understand the work of the parothyroid glands. One of these, the 4 of them put together, is the size of the tip of a pen, what you write with, when you put all these 4 glands together.
Right.
And one of these glands is responsible for converting and balancing matters within the body. It's like they convert phosphor into calcium and calcium into, all sorts of materials which the body needs. At older age, this one of these glands, which is responsible for balancing of minerals in the body, misfunctions. So what it does, it creates a condition which with thymus, leads to conversion and the deposition of calcium in the cartilage and in the bone. You have to, I've developed this technology because we used it. I know exactly what I'm talking about, I hope, is that you have to change the diet. All the changes, physical changes in the body, part of the diet or the acidity of the stomach, you will not allow the phosphor or the sulfur to convert into calcium or potassium or whatever is in the body. If you go back on the old website, which we've taken it off now, and it's one of the pictures, you see the amputation of a toe, which we grown. The toe we grew about 4 or 5 years ago in Belgium. And this lady had a problem. Since 1975 in England, they were trying to solve this problem. Her brother died of the same problem, where one of these glands was misfunctioning, and she was on a tablet, I think about 40-pound a tablet, 3 or 4 of them a day, trying to change this conversion from phosphor into calcium. It was like an aluminum tablet container, whatever it was trying to absorb. So what we did, what actually happened when the doctors in the Warham Hospital in Belgium operated on her the first time, the surgeon told me, Mehran, there is a problem. You know, when we cut her muscle, we get a white stuff, chokes is coming out of it. We usually get blood, but with her, there is a choke coming out. So the gland was converting all the phosphorus and everything else into calcium, and like fat you deposit around your belly, was depositing in between tissues. And this was causing, it's like rubbing sand, was causing the degeneration of the blood vessels. Because, you know, when you move, the friction, and with calcium inside and outside. So I set out in 4 months to reverse the operation of the gland back into not producing any more calcium and keeping the phosphor to phosphor and calcium to calcium. And that's how the amputation came, because the calcification in the blood blocked the blood vessels getting blood to the toe, and it was a gangrene. They had to cut it. So I reversed the condition.
Because she's like 82 years old.
Doesn't matter. It's with the age what has happened. One of these glands has changed slightly its operation. So it's most probably converting phosphor into calcium.
Probably,
and what has happened, if you understand about the structure of the bone in the body, which is another part of the biology, it's very much like meteorites. Go back a step further. We see so many meteorites which pass the Earth. But if the gravitational magnetic field of the Earth and the pull on the meteorite is right, then it pulls it to itself, and we get what happened to the dinosaurs. Now, what has happened, the same position happens in their upper part of the bone of, let's say, the femur or your bone at the joint. Our bone is not solid structure. Our bone is like piano strings on the back of a piano in the same kind of angles. You don't, when you open the back of a piano, you don't see straight lines of strings. They're all in angles, different angles or whatever when the hammer hits it. So the bone in these joints, at these points, the upper points of the joint of the bone near the joints, they have changed their vibration tune. So they're absorbing solid which gets deposited in the cartilage. One of the ways you can get your mother to get rid of it, it's a very slow process, is not to allow any further to be produced. And the way you do it is, if your mother is still mobile,
yes,
and she can walk,
they are doing injections every week with some
cortisons,
lubricants, because otherwise its pain is so big. So
okay. No, she can, if she can stand up or if she can walk. The only way she can. Okay, you can help her in a very, very direct way. You see the results in 2, 3, 4 months. It won't happen tomorrow. Okay. One of the problems which happens with the old age is that old people, because of the lack of strength, they drag their foot. They don't walk. You and I walk. And the way we walk from the heel to the toe. When we walk, we don't put our tiptoe down and we jump to the next step. We put our heel and we go to the toe and we take the next step on the other leg. This hitting of the bone of the heel on the ground creates the right vibration for the decalcification. So all you need to do is to ask your mother to start walking, or when she stands up. You can't do it with her sitting down because the vibration doesn't go all the way up to the hip. Right. If she stands up on a crutch or in a frame, and very, very gentle, very, very gentle, just tap the end of her foot, the back of her foot, on the ground, 10, 20, 30 times a day while she's standing. Just tap it, like the way you tap on the table,
Right, like the ballet guys are doing.
But at the heel of your foot, not the tip of your foot.
Gotcha.
You just tap your foot, but you have to do it standing up. You can't do it sitting down. 20, 30 times each foot a day, or 3, 4 times a day. This creates the right vibration that the calcification does not happen in the what do you call it? In the
cartilage.
In the what do you call it?
Joints.
In the joints.
Joints.
Yeah. Okay. Yeah, in the joints. And what happened? What exactly happened is that the bone, when you play it, the bone is not solid. It's got the strings. This is made of a string type. I was explaining this before in other lectures. So this bone, these strings in the bone play a tune, which is gravitational magnetic field. The strength is equal to the calcium elements in the lymph. That's how we absorb calcium from our body to our bone. They play the tune and it gets absorbed. They play the magnetic gravitational tune, magnet tune. Every time you tap your foot, or every time you walk, this vibration calls in magnetic field a strength to the calcium. So you absorb calcium from your food, which is in your lymph. Now, what has happened because of the old age, the tune plays a distance away from the bone. So because it's become different frequency, different magnetic field strength, now this sits in the cartilage than actually the bone. This happens due to age. So you have to strengthen the tuning, and then all you do, the calciums from the cartilage will move to the bone, and that's it. It disappears. It's a very simple process.
Thank you. I will
Just-
keep you posted.
Yeah,
What
yeah.
the
Just
progress
she
will
has
be.
to. Yeah, yeah. She has to do standing up, just the heel of the foot, 10, 20 times, 3 or 4 times a day. It has to be that the bone vibrates, and then it takes time. It'll tune up. It's like literally a piano tuner. You tune the bone up, and the calciums which are sitting in the cartilage will go back into the bone, and that's it.
Frequency is set.
I understand.
Pardon?
Thank you so much.
That frequency set, let's say to certain, let's say my body is going to react different magnetic.
Yes.
So
yes,
you
your body, your bone
create
is.
a magnet and put on your, healing part, and let's
No,
say.
no, it doesn't work with magnets. No.
Okay.
This is a. If you want to understand it,
This
how
is
it is.
plasmatic magnetic fields.
Yes, go get today. Just go and buy a chicken bone. Buy chicken and break the bone of the chicken of the leg. You see, you get sharp needles in the bone. Yeah.
Yes.
This is how with the birds is. Birds don't need walking too much because they fly. So the separation between these strings is much wider, and you get this needle structure. With a human being, with our weight, we can't fly. The structure is much tighter, but in fact, it's still the same.
Okay, good morning, Mr.
So-
Cash.
Good morning, Vladimir.
I got a quick
Let
personal
me
question.
Yeah, let me ask them. Let us finish with the other gentleman. Can you carry on what you're saying?
What I'm asking, so if hydrogen is in the center of the plasma, it can attract the hydrogen of the center of actually the Earth, correct? They can interact with each other. It depends what magnetic field.
Depends what is strength and what quantity.
Quantity.
Yeah, it's all quantity on it.
Thank you.
It's very much how much you have.
Okay.
Sorry, Luzmil.
Yeah,
First of all,
that's okay. Yeah.
good morning or good evening to
Good
you.
morning. Yeah, it's a night here. Anyway,
Have you received my email?
yeah, I'm feeling it. Yeah,
Okay.
I'm feeling the forms. Yeah.
Do you want to tell people, or you don't want me to tell?
I
we-
told them
quiet.
so they know.
Okay,
Yes.
as most of you know, we have accepted Ludmila as part of the first group of knowledge seekers in January or February, and he has received a package of the foundation to join to to be one of the first groups, and I hope we can work together very closely. Carry on.
Yeah, I hope I'm gonna be smart enough for that. I have a personal question. Do you deal with diabetes?
Diabetic?
Somehow? Yeah.
Diabetic is a resolved matter for us. We run tests on 1 and 2. Both are totally reversible. 1 takes up to 2 years to reverse to 40% of insulin usage, and 1 can be reduced to no insulin. 2 can be reduced to no insulin usage.
Yeah.
The diabetic condition is created by the pressure on the blood vessels, stress on the blood vessels, and then that transfers to insulin production, insulin use.
Yeah. So another nasty question: do you use a reactor for that, or you do it some other way?
Yes, I use a reactor. Excuse me, just hold once. Yeah, I built a special system for it. We completed the insulin, or diabetic condition 2 about 5 years ago, and diabetic 1 about 3 years ago. Just 1 second, please. Just 1 second. Diabetic is resolvable. Diabetic is very much a stress point, and it's a stress on the blood vessels, which goes back to sort it out. It goes back to the insulin and the rest of it which you use.
Yeah, probably that's gonna be the first reactor I'm gonna make. Looks like it.
Yeah.
Okay, so another question. I sent 2 pictures there.
You
That's
have
my
wait.
vacuum system.
I am doing something else while I'm talking to you because it's something important.
I sent them at the beginning of the
Okay.
session.
Just give me 2 seconds. I have to do something on the internet because just then I'll be with you.
Congratulations, Mr. Ludwig.
Yeah, thanks.
For your learning you're gonna have.
Well, it's gonna be a lots of fun on this age, but that's the way it is. Nothing you can do about it.
So you
I
have to
think
teach
your
us.
CV does it all, huh?
Well, I don't know. I'm just getting old and stupid, that's all. No
You have
matter
to-
what.
That's not
So you
true.
have to be our teacher then.
Well, that's the easy part.
You're getting older and wiser, man. Don't say that.
Gentlemen, I have to come off for about 10 minutes, 5 minutes, something important, and I come back on again. Is that okay with you?
Yeah, sure.
Yeah.
Continue.
Yeah, okay.
We can carry on for hours.
Yeah. I'll be listening, but I have to work in the background.
Yeah.
Okay, good.
Okay. I have to do something. It's urgent. It's for the foundation.
Thank you,
Okay.
Mr. Cash. We'll see you in a
I
bit.
stay.
Very much.
I stay online. Okay.
Thank you.
Yeah, okay, thank you. Okay, guys, anyway,
Just
so
to say first, Lamilda says hi. She's watching on Justin TV right now. She's appreciating some of this conversation.
Yeah,
Go ahead there.
she asked me for the time and where she can watch it. So
Okay, good.
yeah. Okay, so all of you guys, I sent my vacuum system. If you want, I can tell you something about it, or
That's the front,
your
back pictures. Is that correct?
Yeah, it's 2 pictures. It says back and front. At the meantime, Mr. Cash is gonna listen and say if I'm correct or not.
So do you want to describe your system or something like that, or?
Yes, you can. I don't know if everybody has the picture though, but you can see.
Yes, I got it.
Yes, I've got it also.
The far right side, that's the roughing pump. It's labeled 5C. There are 2 pipes going off of it. One of them goes into the turbomolecular pump, which is the middle one above the bucket. The bucket is the water cooling from the turbomolecular pump. And
Can
on
you
the
send a picture again, Latmil?
Yeah, just give me a second. And the far left side, that's my discharge cylinder. That's where the reactor is gonna be discharged. It's a stainless steel bucket for a beer. That's the most easy thing I was able to find. So basically going from the roughing pump, you can see there are 2 pipes. They both have valves. Unfortunately, the valves are not holding pretty well vacuum, but that doesn't really matter. One of the pipes goes into the turbomolecular pump. The other one is going to discharge completely the discharging cylinder without the help of the turbomolecular pump. if I expect to have some burning or real plasma there. So basically I bypass if I can damage the turbomolecular pump. And what you can see at the back, there is a third pump, which is very small, which is used, I don't care for what. Like if I discharge plasma through it and that becomes damaged, that's just simple regular pump which has no price almost on the market. So you can do whatever, you can vacuum gases, you can vacuum direct plasma and so on and so on. And the same pump, it has a valve which goes into the system. So basically you can control pretty much everything everywhere. What you can see on the left-hand side on the top, that's the vacuum gauge. The simple solution was for me, this vacuum gauge is basically eating batteries. So I have a small transformer which is powering the vacuum gauge with 9 volt. And at the meantime powering there is a water pump into the bucket which supplies the turbomolecular pump with water, basically with water under pressure, to be able to cool down. So that transformer basically supplies the pump and I can use it for anything else, which is about up to like 13 volts. And at the left-hand side, that's the reactor discharge cylinder, which is stainless steel. I would make a picture inside. It is pretty much very interesting sealing inside, which is, as you can see, the cover. There is another flat plate down under the cover and a small sort of a screw. And there is O-ring inside. So the second plate, which is under the cover, basically smashes the O-ring and seals the cylinder through the O-ring completely, which is very, I would say, interesting concept about it. Basically, tidying the both plates together smashes the rubber so it seals. That can be used into the reactor also. Very, very easy kind of sealing of the hull. And you can see also at the front, that's a vacuum grease, the green small tube there, which I use to seal. The thing on the top of the deep vacuum pump is sort of a sphere. It's mashed here, but it's sort of a sphere which basically allows the air to run without any resistance when you vacuum. So you can easy and very convenient get the deepest vacuum you can from your turbomolecular pump. What my pump guy says, whatever you use for a top cover, whatever the hole is, that much you suck from the system, which is pretty much true, because if you have a flat surface on the top and just small opening for the pipes, basically 90% of the propeller of the pump is not sucking anything. It's just sucking in the middle. Here, this way, you vacuum the entire space and use it to vacuum way faster and way more accurate. So
it's about the flow section of the pipe, right?
Yeah. If you have like a flat cover on top of the pump, basically whatever you have for a hole in it, that's about the size of the propeller working. So if you have like 1 inch hole, basically just 1 inch of your propeller, which is about 6 inches, is really working. The rest of the propeller is just not sucking. That's what it is. This way, having it like a sphere on top, basically you use the entire propeller to suck the air and throw it out. So that's way more efficient way of pumping, I would say.
Right, because it sounds like it's pulling in the molecules through the hose, but then having a place to gather it and then having the full suction of
the... basically it's creating something as a vortex to pull everything out.
Reverse vortex, upside down.
Yeah.
So, you have any motor in the down part, or is just a static reactor, one core, and it's not rotating at all?
No, there is no reactor here. No, that's just the vacuuming system. There is completely no reactor here. The reactor, you can see it on the right-hand top corner somewhere there, but...
I got you. Just, okay, I understand.
That's just the vacuuming part. It's kind of complicated, big system, I would say, but that's the way it is. And I built this shelving, and on top of all the shelving is on wheels. So basically you can roll it pretty much anywhere. It's free. You can use extension cord for the power, and you can move it everywhere fairly easy.
And let me have you ran three tests?
Yeah.
And what kind of...
It go down to 300 micron for like 10 minutes, not even that. And without the turbomolecular pump, just the roughing pump. What I don't like in the entire story is these valves. They don't hold well vacuum. They hold perfectly. I tested under pressure for leaks. It worked nice. But the only problem is these valves, they don't hold vacuum. They hold pressure, but not vacuum.
I found the same thing with those.
So I don't suggest you to use quick open valves.
Like bolt valves.
Yeah, it's, yeah.
Well, you need proper vacuum valves.
I have different setup. I'll show you guys if you like. It's not complete yet, but it's getting there.
I've been having trouble with brass lever valves that are getting gouged, and they lose their ability to hold vacuum, and it's a real pain.
Is it okay if I show you?
Sure. You're gonna turn our video, I guess.
1 minute. But I have a laptop, so I want to move. Maybe it's going to be not perfect, but okay. This is the setup. This is the valve. I think it's a swage locks. It's meant for vacuum actually, and it's holding very good vacuum. If you have a leak, you can use silicone actually. You can put the silicone where you think it's a leak is, or you can wait minutes, then turn your pump, and it will seal it. So don't worry about the small leaks. It always can be taken care of. And here's my turbomolecular pump, actually, which I'm going to put on top of the roughing pump. And the lining is going to be like the, on a stand, it's going to be the control for entering gases. Actually, this is the whole vacuum. And from here, I'm thinking to put, there are devices
It's a micro mass gas mass distributor, which is you can have several, let's say, hydrogen, nitrogen, argon, 5, 6 gases to connect, and it's going to make a mixture, exact mixture, what you like to enter to, your core. It's called gas mass flow controllers. You can distribute your gases, very little or the mixture you like, certain, by molecular count.
What I would suggest you, to my experience, there is lots of vibration. So build something as a shelving and have you can have your turbomolecular pump over the roughing pump, but don't expect one of them to hold the other.
No,
because there is lots of vibration there, so
I'm not. It's
better to.
Yeah, I'm using flexible hoses, thick flexible hoses.
Yeah.
Which is going to be connected, so it's going to hold a steady vibration actually.
Yeah, I try to do the two pumps into one table, one level actually, and almost broke the table. So that's why I'm telling you there is lots of vibration there.
My roughing pump is pretty good actually. When I'm turning it on, and it's I'm using and oil is very important, Ludmil. So you have to use the right oil for your pump. So
well, I'm using whatever Liebold gives you. It's about $100 for gallon, I think. About 3 liters. It holds about 400 grams in one charge.
The good stuff's about $2,500 for 4 liters or about a gallon.
That I cannot afford.
Yeah, but if you were in a certified lab, you'd have to run that stuff because otherwise there's a fire hazard from the regular oil, and an insurance company wouldn't insure you.
Yeah, well, I will write certification to myself, so that's fine. As far as I'm concerned.
Yeah, so, and imagine if you put some water through your system, you would contaminate that expensive oil too, and at $500 an oil change, it'd be pretty expensive.
That's for sure. But I don't see where is gonna come the water from. Unless there is some moisture in the reactor or something.
There's always moisture in the air, and there's always a bit of moisture. That's the first thing that gets drawn out of the vacuum. If you find that your vacuum pump gets stuck on about 1400 micron, then that's the water coming out of the system. It takes time for the vapor to get pulled out, and once that's out, it goes on to other gases and so on, and drops down more rapidly from the 1400 level.
Well, I don't know. I don't see where it's gonna come from. Not for something else.
For me, I was doing experiments with boiling water inside the vacuum, which is great fun, watching water boil at room temperature. But I only did that once because I contaminated the oil in my vacuum pump and had to change the oil because it got cloudy immediately. So that's a massive amount where you evaporate an ounce or two of water that way. But every time, like for example, if you open the valve too quickly to the chamber, you'll see it mist up right away. As the pressure changes, it causes all the water vapor to go into mist that's naturally in the air. Air is something like, 5 or 10% water vapor, something like that, I think it is.
What I have on my vacuum, on my roughing vacuum pump, there is a knob there which basically I'm sucking. There are 1, 2, and 3 marks on it. So depends what exactly you're trying to suck. Looks like it. I'm not pretty sure how that works and how that separates, but so far I'm okay. I never damaged my oil so far.
Yeah, it's true. When you have a better pump like most of you guys have, the better pumps have that bypass, and that can really help with the oil backup problem, the oil vapor backup problem, and that sort of thing that I would tend to get with my cheaper pump.
Lots of fun. Lots of fun and other expenses, of course.
Yeah, it's really a situation of trying to round up a herd of cats when you're trying to get rid of vacuum leaks, I found. So it's a challenge. It's incredible how many tiny little leaks can form. How can the same fitting be fine one day and leak another day, and this kind of thing? It's very mysterious. Like with your system, Ludmil, you should be able, with your backing pump, you should be able to get down to like 25 or 50 micron quite easily.
Looks like it. At least I don't see any challenges getting down like to 300.
Well, 300 is pretty easy. I can do that in about 10 minutes or something like that.
Yeah, well, the problem is this globe on top smashed. And I order one to make from copper, thick copper, but I haven't got it yet, so I don't want to run it and drop this pipe inside the propeller and break everything.
That would be the end of that.
Yeah, so that's why I don't want to run anything which is gonna damage it right now. But pretty much, it's fairly easy to get down there, I guess.
Like if you hooked up your vacuum gauge directly to your backing pump, it should take it down quite quickly within a minute or two, probably right down to its minimum. I'm not sure what your pump does. I think it's even below 10 micron, isn't it?
It should go down to 1 micron, I guess.
Oh yeah, that's great.
Yeah.
Mine will do about 25 or 50 is what it's rated for. And they say the turbo pump is supposed to have 70 on the inlet, and 40 on the inlet and 70 on the outlet, ideally to start it up. But they also say if your chamber is small enough, then you can start the turbo pump practically at the same time as the vacuum pump. In some cases, at the same time as the vacuum pump. By the time it revs up, it takes 4 or 5 minutes for the turbo pump to rev up all the way. And about halfway, it starts to kick in pretty good, and it'll pull the chamber down pretty quick at that point. I turn on the turbo pump now with 300 or 400 micron in the system, and it protests a little bit, but it'll pull it right down to 14 micron really quick. And that's all I can get out of my turbo pump right now. So something's happening with leakage or off-gassing that I have to deal with.
Rick, use silicone. I'm telling you.
There's no place to put the silicone because it's not leaking at like a joint in that system.
Then it's outgassing.
It's probably off-gassing from the polycarbonate that I use as a plate, the main plate, rather than stainless.
Correct.
So I can see dealing with that in a polycarbonate chamber when you're drawing a vacuum. You can kind of compensate for any losses coming out of the chamber. But the actual turbo pump itself has to have a, proper metal, I think, rather than...
Actually, you have to lose very little plastic, as much as less as you could.
Yeah.
Like a connection from your controller board to, let's say, your reactor. That connection, yes, you can use plastic, but not all of the system, because you're going to have lots of leaks and outgassing too. So what I'm trying to do, built with standard steel, it's more liable actually.
Yeah, that's right.
You know,
No.
it's the best thing I can find. I found it in the market. It's a Swagelux. You know, they hold pretty good vacuum. Actually.
Yeah, I'm talking about the bigger fittings as far as from the turbo pump to the valve. And for me, I've got the 160 size, which is double the size of your top of your pump there. The inlet of your pump, which is an 80. And so I got to go from the 160 down to a KF40, and that's a pretty big jump. And I just used a polycarbonate plate and kind of made it up and had to sort of do some machining on it and so on to make it fit. And I'm not real happy with that situation. I think it has too much dead air space because of the way I made it, and it could be leaching through, and it could be off-gassing, all of those things, besides leaking. So it's time for a change of...
No, the off-gassing is most of your problems. Is going to be like even with your reactor. Even with your reactor, you can do layering inside that it can keep or extend your you know, how long you can keep the plasma inside the reactor. I think layering is it's for that. It makes it more secure, not to outgas. That's a biggest problem you're gonna have with these materials because they always outgas. So I have to, like Earth, you have to put layering, you know, the hydrogen inside to rotate longer times. You know?
Yeah, one of the problems with the off-gassing is that if you try to draw a very deep vacuum to start with to clean everything out of the chamber that doesn't need to be in there, that will interfere with the reaction, then any off-gassing won't allow you to go into the deep vacuum and just keep off-gassing and off-gassing, off-gassing. You know, keep pumping and pumping, trying to get down and working it. It'll seem like a leak, essentially, and you'll never get down. Any tiny wee leak means you'll reach a wall where your pump won't pump any further because of that leak, essentially. So it does a similar thing with off-gassing. Sometimes it gets confused how to determine whether it's a leak or it's off-gassing because they're very similar symptoms.
Right.
Off-gassing can take years and years to lower.
Right. Like
that's the longevity of your reactor, you know.
You consider the concept of a fingerprint, the oils in a fingerprint could take 24 hours to vacuum out. Then the oils inside of a rubber hose or a plastic hose that isn't rated. Like I recently found that my nice hoses that I had custom made up at my industrial hose place, that was the best vacuum hoses they had, they're good for 29.9 inches of mercury rating.
Please don't use no rubber.
Well, they're not rubber. They're PVC. They're rated for vacuum. They're supposed to be used for vacuum, but they're not rated for a very deep vacuum. They're rated for 29.9 inches of mercury, which is what does that work out to? Something like 1,000? No, more like 40,000 or 20,000 micron or something like that. You know, it's actually it's close to 30, but it's still a long ways from 30. When 29.9 is nowhere near as close as 29.9999, which would be more like 10 to the minus 5 or whatever millibar.
Just try to avoid any kind of rubber, plastic when you're vacuuming your system until your control board. You know, then the rest is a small distance, so you can handle it. But the board and the vacuum system, it has to be, I think, all standard steel. You know, that it holds the vacuum better. That's my opinion.
It would be nice if we can find a way to do it without the vacuum.
Without the vacuum. That's next.
Rotated.
Rotated, correct.
Centrifuge it.
Centrifuge.
Once the gases are added, it's not really a vacuum anymore anyway. It's a partial pressure, correct?
Oh, you're just trying to make your system, perfect. So.
There actually was a hint there today regarding that. If it was a liquid reactor with liquid hydrogen, then vacuum would not be necessary.
Right, good point.
What about if you have a liquid plasma? You've done the job further.
No, I want a magnetic-based plasma. That's all.
But Mr. Cash, here a quick question. The Russian people did some tests with extremely high pressure oil, for machine tools, for hydraulics, and they created plasma by extremely high friction between really liquids without any vacuum. So do you think that that could be a path? I'm guessing that you are naming liquid plasma.
That there are planets, and actually the stars work that way. One of the misconceptions, the liquid hydrogen or liquid plasma. Plasma becomes liquid itself, like anything else, if you know how to do it. And the high pressure gives you that position. But what can you do with the plasma? It's just using the plasma. The point goes back what I said in the beginning of this talk today. You have to create a condition that you get a homogeneous plasma out of a soup of plasma, not just one plasma. And because you have a magnetic field and dynamic field, this happens automatically. Plasmas open up together, become one. And this central point creates
You are trying to suggest that there is a spectrum.
Yes.
Yes.
Okay.
There is a spectrum. There is a way that these things are done. I had a very interesting, as I said, talk with a professor yesterday. I gathered because he couldn't understand what I was talking about, so my work was not correct to him. So it's what you understand, and it's a new way of understanding. In a single course, you can create one single plasma from amalgamation of other plasmas which open up. It's just you create a condition that they open up together. But at the same time, you have created a enforced fields or containment with your core that this plasma has to behave or do something. In one of the reactors, we put, I showed it to the guys a few weeks ago, in the bottom of the half-sphere reactor, we built the plate which keeps the half-sphere to itself. We made embedded rings of copper. So I think it's about 4 different rings, one right in the center and 3 more. But these rings are sitting literally touching the surface of the plastic. But it's totally sealed that we can measure the behavior and the strength of the magnetic field, the strength and the flow of the field between each ring. And this was made for me by the scientist in Tehran because we wanted to see the behavior of the plasma. So
basically,
we could
you measure some induced currents, right, in the rings.
It's not currents. In a way, yes, but in a way we monitor the flow of the field from one point in the circle to the next. It's just
sort of
concentric.
gradients.
Yeah, it's a concentric rings. So, so it's in the center. We know it's a 0 point. It's our reference point, and then we measure between the other rings if and how much of the fields are converting into electric current or different currents or different flows. And this experiment is very interesting. It's because to make such an embedded copper in the plastic, it took quite a long time to convert my thoughts into a material which fits into a reactor. So we see changes, we see drop in or increase in different parameters. Then we can see different gravitational field, magnetic fields, different position of the plasma. The people who
this
join
will be
us,
like a sort of control tool or examination.
no, it's an examination tool. It's an examination tool. I mean, people who come to work with us, they will see these, because when we open the institute, everybody will have a total free hand. In everywhere you can go and do whatever you like in the lab. We don't control anything. It's not a classroom condition. So we see what we come up and how people explain different things. And
Yes,
this
but
is
that
one
is
of
generating
answers.
another question here, and maybe you could, as we are getting, how to say, focused, maybe you can explain a little bit better. You said in the previous lectures and in the papers that wherever you are in the universe, you use whatever material you have. That means different magnetic fields that will be different in the strength of one electron, gravitational magnetic field. So irrelevant of the size of the two fields, have to create this difference to have a flow. So my question will be, what's the value of that one electron gravitational magnetic field? I mean, what do you measure it, or how do you quantify it, or you know what I mean? Supposing I can do two magnetic fields that are different, but how
You
do you know
see,
exactly
with
what measure to differ?
Matter is all around you.
Pardon?
I said matter is all around you.
Yeah, but the matters become matters, even they look matters, but different according to the gravitational magnetic field center they respond to.
Right,
Creating. Yeah, carry on.
The question was, what is the gravitational magnetic field in the strength of one electron, as you said in the papers? What's the value, or how do you measure, or in what do you express that strength?
How deep you can go?
Depends. Yeah, in a way, Mr. Cho, you're right. But it depends on where you are according to the center of it. You measure different strength. We can go into mega, or we can go to micro levels of measuring the strength of the fields.
Right. But the question was not about the strength of fields, because we know how to measure that. The question was, what is the magnetic field of one electron? Because you said that difference should be.
Yeah, it depends where we measure.
Strength.
Yeah, it depends where we measure, where you want to measure it. This is what I explained a few minutes ago about the electron moving to the center below the plasma of the proton as a layer.
So, Mr. Keshe, if it's inside out, that's when it's infinity. You don't know how deep you can go.
Exactly. The dead end is, or the bottom end is the highest strength of gravitational magnetic field you get.
It's infinite too.
This is like a center of the solar, what do you call it, the universe. You have a center point in the electron, then you have a center point in the solar system, and then that has a center point in the galaxy and forward to the universe. You see, if you read one of the papers, let me just say something. if you read in one of the papers, I explain not necessarily the fundamental atom in universes is all the same and hold the same amount of magnetic gravitational field or principal matter, amount of principal matter.
Okay, so here, just a question, like in the mainstream physics, they have the Planck constant and this and that. What will be that value?
Don't know, it's got to be measured. I don't know.
Value
I'm not a
whatever you
theoretical
want to be.
physicist. I'm not a theoretical physicist.
I think value whatever you want to be.
You see, that depends where you, how deep you can go into this, into the center. I don't think we have the tools, or we at this moment, or we ever attain tools at this foreseeable future to go to the highest strength. Yeah.
Supposing you have a magnetic field of 1 Tesla, whatever, right? So in order to create a second magnetic field, to create a condition, as we explained, I have to know how much I will be that 0.98, 0.95, 0. You know, I mean, as I don't know the gravitational magnetic field of 1 electron, how much less should I make the second one? It's a very practical question.
I don't understand what you're talking about. Can you repeat it?
So you suggested that in order to have a plasma, you have to have 2 magnetic fields that will differ in strength with the value of 1 electron's magnetic field, gravitational magnetic field.
Repeat that.
So,
repeat. Can you repeat that again, please?
So you stated in your papers, right, that in order to have a plasma, you have to have 2 magnetic fields, which one should differ, will be more or less one of the other, with the equivalent of magnetic field of 1 electron. So if I don't know that, what will be the difference I am creating to have the condition?
This is what we do in the multiple reactors to measure the magnetic field strength. Just 1 second, please. I have to answer this one.
So for those who haven't seen my latest work, I'll just post a link.
Rick?
Yes?
Are you there?
Yes, hello?
You remember a conversation yesterday we had?
Regarding which again?
Hydrogen. It interacts. That's all you need. For now.
Well, show me. That's what I say, show me.
I will.
I know you will.
I have this material which I wanna, actually, it's a polycarbonate, and it's actually very easy to CNC machine. So, and I have a design already. So I'm just having trouble with this my new Mac.
Do you want me to show some of your pictures, Armin?
Yes.
I'll see if I can get them set.
I have new ones, the one that I want to create, this one. So you will have an understanding fully. That's what I want to ask Mr. Kirsch, if it's a right material. Actually, material, that doesn't matter.
Why you want to machine it?
It's easy. I want to machine it, the design I created, so it's easy.
Yeah, but you can just bend it if it's plastic.
It is not plastic, it's a polycarbonate.
Yeah, same thing.
It's not a tube. It's not a tube, though. This is solid.
No, you can have a flat piece and just have it bent and create it to whatever you want.
How I'm going to do that?
Well, you can do it fairly easy.
Armin, you can put in like a 3-axis CNC mill, and it can machine for you there.
Yes, I know. I already have I already have the CAD drawings that I can give the.
Yeah, I'm trying to set that here.
I done that. Wait, do you know Mac? Actually, I have a new laptop, so I'm trying to connect my USB, and I don't know how to open up a file. I know Mac, I know Microsoft, but not this one.
To open up a file, what are you trying to open up?
I have
Do you have a desktop on your Mac there? Or, okay, got that.
File, so I just want to open up, and I don't know how to open up.
Okay, when you put it into your computer, does it show up on the desktop? On your screen? Your computer screen as it should show up as a drive. Or you'll have.
Okay, I got it. Okay, and now I'm going to post it. Thank you.
There you go. And then you should double click.
So Armin, in what did you do that? Like in SolidWorks or what kind of software?
Here,
CAD software.
The guy converted so many actually types that if I give any machinist, he created 3 files. I don't know.
No, I'm saying the modeling of the sphere in CAD software. What do you use, like SolidWorks or?
SolidWorks.
Okay.
I'm not the one who is doing that. I know a little bit about software, but
Gotcha.
the guy is a friend of mine, so he's doing the design what I like him to design the way. Anyway, let me post a few pictures. Did you got this one or no?
Yeah, they arrived.
I'll try to.
Hello, I'm back on again. Sorry about that.
I'm sorry.
Try to do
Okay, you were explaining how to measure the magnetic fields.
I have a system. I'm trying to explain to you. I have a system I can measure. This is a difference. I use this quite a lot for different applications. With the system we have, we can, let's say we want to make magnetic field of, let's say, copper. Yeah?
Okay.
So we measure it. This is a magnetic field of a copper. We drill a hole in the copper in the center. We put our tools in because it cannot be anything but the copper because we are in the right center. And then I go to my reactor and I produce the matching fields in the same proportion.
Okay, so just a second to make sure that I did understand. So you take a bar or whatever, piece of copper, right? And you drill a hole into it and you insert this measuring machine you have.
Yeah.
And that machine will give you the magnetic field inside in that hole.
Yes. This is how
inside
it's
the
done.
hole of the copper.
In the hole of deep in the copper, yeah. Because there is nothing else. Yeah. So this is what is done by most of the people who have these kind of facilities. You don't have it. We use it for different aspects for different purposes. And
I got you.
when I what do you call it? When you want gold, yeah, you test
so
it
just
with
for
a gold.
argument's sake, as we don't have this equipment, you could tell us, okay, for the copper you need 0.667 Tesla.
No. But with this, you take three-dimensional.
Right, I understand that.
Three-dimensional. In that direction has to be this. In that direction has to be this. In that direction has to be this.
Yes, I did understand that.
Yeah. So you take it, and these things are computerized programmed. So
right.
And so this is how we measure gravitational field of our system. We stick the
So
system.
now in the reactor, you put like a central reactor in one place, and after that, in the vectors in space.
We look for that. Yeah, we look for that gravitational magnetic field at the center of the copper. In the
What I'm trying to say, that machine will give you the vectors in which the magnetic field strength has some values. So after that, as you in the first reactor, you have a spherical field. I mean,
we don't go in the reactor. We don't go in the reactor. We do the measurements outside it.
Right.
Yeah.
But for creating the condition, you start the first reactor, and after that, you position more other reactors in some specific position in space to create the condition that you measured with the machine.
Yes.
Oh,
yes.
Got you now. Understand.
This is how I understand. This is how I worked, and I think in the future we need several number of these systems for measuring the space measurement in these things.
Can I ask you something? Because I think I may able to help. I mean, not only you, but the guys in the group with this issue. The sensors themselves that you put in the copper hole. There are some hole sensors, or I mean, something that you could buy in a reasonable.
No. These are a specific, very, very specific sensors. They are the size of a tip of a pencil.
Right, but they can be bought commercially, or
I don't know, because these are I don't know, because we got these built for us.
What I'm trying to explain
the whole
to you
thing.
is,
Let me say something to you. If you get a pen in your hand,
right,
on the head of this pen, sensors.
Right.
Yeah. So we have 3 sensors on the tip.
Right.
These are all together the size of a tip of the pen, all 3 of them together. And they are connected to certain computer programs and wired up that way. So that's as far as my knowledge goes. So you can't ask me something I don't know.
So the question will be, let me explain to you something. This Hall sensor, I don't know if this is what you have, are manufactured by a couple of companies in this world on the customer specification. In other words, you tell him what kind of field strength you believe that you are going to have. Let's say, I don't know, 0.1 Tesla, 1 Tesla, 10 Tesla, 100 Tesla, whatever you have, and they do it for you, custom. And the price is maybe in the $100, $1,000.
The system with this full system, the box, with one for a very low magnetic field and one for a high magnetic field with 2 sets of sensors, has cost us, I think, about 10,000, 11,000 euros.
Right, but what I'm trying to tell you, only the sensor, that pen you said,
we
are speaking about hundreds of dollars, not more. So
I don't think so. It could be even less. It's the program, it's building up the system which you pay for.
Right, but this I'm trying to explain to you. The program can be written by some of us. The only issue that I'm kindly asking you, maybe until next session, you could maybe find if the sensor you was talking about, only the pen tip, is a Hall sensor, whatever it is. Because
what do you mean by a Hall sensor?
Beg your pardon?
What do you mean by the Hall sensor?
So that tip of the pen you said, that is the real magnetic sensor that is detecting
the Hall
the
sensor measures the magnetic field, yes.
Yeah, you can buy these. I think you can buy these off the shelf, or you can buy it from
that was my question.
Place. It's a matter of finding, what do you call it? Finding how to operate it that you can use it.
Right, but there is another topic. We can do that. The question will be the range. For example, you could ask the company to build you the sensor for like 0.1 Tesla.
Yeah.
1 Tesla, 10 Tesla, 100. You know, you have to tell him.
Yeah. But I don't know. This is something I think in the future, people who come into the foundation, they can build these things and write the programs. But when we wanted it years ago, it was not there. So we had to get it built by the people who know what they are doing.
Gotcha.
This is the problem. Yeah. So you got to realize if I'm going to spend all my time to build things, I won't have time to do other things. So
Right,
for these
but
things, we go back to the experts who we find and we trust to do things.
right, but I was telling you this because in our group, the gentlemen, each of us have their own, how to say, expertise in different fields, and if we don't have ourselves the expertise, we may know people who do. So
I think this is why the strength will come in the future, that as a team, this is why, I don't know if you know it or not, let me explain to you. Due to the what happened to our server on Sunday, we deliberately kept the server offline. If you go, Keshe Foundation server is offline. It'll be offline for, we don't say when, today, tomorrow, whatever. And before we go down offline, because of the document which I put on the peace talk with Iran, the certain government decided that they want us down the line. So they attacked servers, bank, and they brought the whole rack down. 24 servers came down together.
Mr. Keshe, can I ask you something?
Hold on. Let me explain to you.
Just a second. I am quite familiar with this kind of computer issues. So basically, if you do not host your server somewhere, but you put them in a physical place, you just get an IP address or a range of IP addresses like Microsoft, and you do your DNS servers through the Internet Authority. You could have your own system administrators, as they are called, and all these troubles you are saying about that could be solved by tunneling. In other words, you allow certain people to get in, which are verified, and you will not have all these kind of troubles. I'm assuming that these commercial people with whom you are hosting, you know, they're not really knowing what they're doing, if I may say so.
It's center. No, what happened is it's a long story. We can't disclose it, but we have spent tens of thousands of euros in past 2-3 months to avoid a pre-planned attack on the foundation. If you notice, past 2 months, 3 months, we've been up and down quite a few times. So now we're trying to come to an arrangement to sort this thing out. It is beyond any control. This because it's the way the attack is taking place. They went to hijack the domain. We secured the domain. It couldn't happen. They went to the server of where we hold our emails. They have downloaded our emails, stolen off the server of this different company totally. And then on Sunday they decided, we knew we were waiting for this. So I instructed that we're not going up. We're staying down till we see the position. And we're going to go back up very soon, in the next few hours or a couple of days, when we feel safe to go back up. But in meanwhile, as you said, you have different expertise in different part of the group, or you know people what to do.
Coming back to the measurement.
Yeah.
So,
okay. No. Let me tell you. Let me finish something. This is important for you to know. Before we go down on Sunday, by then we have already sent acceptance to 4 people who we think are assets to be as part of the first group. So we are choosing expertise according to what they can bring in to the foundation, and as a teaching program, as part of the learning circle. Then these people who come to be as part of the first group, then they communicate with you lot. They teach you lot, and between you and the people you know or in the groups of you work with, you can come up with the solutions and feed back to us. This is what you got to do. This is what the setup is. So you tell us this is, you can buy this and you can write this program, or somebody in the group has written a program that we can produce the system in the institute. We'll do so.
But let me explain to you something. Our discussion today was very good, I could say, because it clarified a lot of issues. So in order to enable gentlemen's, in other words, only today I understood what do you mean by set the condition of the specific condition of copper. So now, if I understood this, how do you determine it? And after that, in order to replicate the condition, now I can use other people and say, hey, you have to, or I have to do a software to do this and this and this and that. So you follow what I'm trying to say? You clarify.
This is the reason for these workshops.
Right.
This is the
but what I'm trying
purpose
to
of
say,
the
until
workshop.
today, I really didn't understand what you mean by creating the condition, frankly speaking. And
Yeah, but
probably
in
the
the
other
other
gentlemen
people
not.
understood. Some people understood, and other people understood different way.
That's correct.
That's why
We
this is the
definitely-
purpose of these workshops. That we talk about it. We go into more detail. That somewhere down the line, people understand the position.
Right. So now I'm speaking only about myself. So as I understood this, I can go and say, hey, you guys have to do a software like this. You have to look on this kind of sensors. You have to take a look on this and that and get back to us.
Are these part of your Cash Foundation team?
I don't think so.
Or these people, some people you know?
There are some people I know and they're working, like in universities and this and that and teaching.
You can include them.
In the regular, institutional system of teaching. So
There is no problem in this. It's good because in the long run, let's say in 2-3 months' time, when Ludmila and other people are here, and we carry on with the workshops. We don't stop with the workshops. But in that time, it'll be a group workshops. It'll be 19, 20 of us sitting around the table, and anybody from around the world can ask questions. Then people say, okay, we can build this. I understand I can do this. And the feedback, and this is what is the structure. You all can't be here and we can't be all there. So somebody who can produce this system, you say, okay, I can produce this system. And that's good enough.
Because I want to give you an example referring to what you said today about the scientist with whom you was talking. I think the main psychological barrier regarding plasma is that all the people understood that plasma is a cloud of ions and electrons. So unless this is not very well explained from the beginning to the guy who is coming into the group, is going to be very confusing because he will understand plasma in that way and he's dealing with something else here. So the point I'm trying to make, because I did teach into the college, university in the past, is that let's say if you are the professor to keep the structure of the main stream, now you have to have some assistant professors which understood properly the topic, and the new coming in will be taking teaching from the assistant professor, preparators, whatever, assistants, however you want to name them. And after they get up to speed, obviously they could ask you questions and they come with the new. In other words, you're not going to waste your time to train the entry-level guys.
This is why we started with this new group, a small group. And I explained to the people who are part of this group, these become the teachers and the structure setters of the future.
Right.
Because this is how it has to be. I'm not going to be here, for indefinite. And at the same time, what you learn, you add your own flavors to it. So we go to the next point. But people like the offer of the place has gone out to 4 people yesterday. And so each one of these brings a different flavor or different speciality and expertise. So we have to see, we received further applications which some of them are useless because it's no good for us, not useless to us, not them. And some are people we don't need at the moment in part of our teaching. So I start teaching that at the same time they start teaching people like you outside, and there is a talk if we can do, we do like a week seminar, scientists from around the world come for a week. You don't need to be here for months and years, but specialized, targeted and done. And this is going to take organization. We got to go that way. So I teach to 2025, and then 2025 will teach to few hundred outside each, and then a few hundred you have to teach the others. But overall, when we see something and we need something, you say, oh, it can be done this way. We get the feedback. You come in, or the people who are in contact with you bring it in, and it's done. As I said in our press conference, the titles, professorship, doctors, and lecturers stay outside the gate of the institute. We work as one team. Nobody has any ranking.
I was not speaking necessarily about the, how to say, titles in the, what paper you put on the wall.
I read something very interesting in a blog a couple of days ago. They know that we are setting up this institute, and now we are choosing people to come in. I don't know where I read. Somebody wrote somewhere, Keshe now is making disciples. You understand?
Yes,
so,
we understand.
It's a compliment, Mr. Keshe, right?
Yeah, it's a compliment.
No, but
there are at least 9 of us here.
No, I think we are looking about a couple of million disciples, but but this is what people see, and it's very strange. I mean, let's walk away for a few seconds from these things. Yeah, let me tell you something, because we've been too serious this morning and there are too many pressures everywhere. We are getting people who call people who know us to get their sons to be in this first group, or their father, or their family, just because they know me, or they know somebody in the foundation. Can my son be in the first group, or my grandson be in the first group? And I said, the only thing is, at this moment, the first group I choose on the merits which I see can be a benefit to the initial structure. And after that, it's not in my hands. The people who are around me, they decide, because they know whose knowledge and expertise is valuable to the foundation to accept. So the first group who join us, or what they call this disciple group, I call them, or what they call it on the internet, they decide who and how they're going to expand it. This is. Pardon?
If you're not a scientist, so you cannot be accepted if you understand, the technology, but you're not a scientist, and you're not a high-ranked, professor. Yeah, I have no titles, but I understand this technology.
Yes, but it's not about that. It's about prerequisites. In other words, I will try to explain this. Let's say if you want to go to mechanical engineering, right? To get admitted into the faculty, you have to pass an exam on mathematics and physics. If you don't get,
we have no exams in the foundation.
No. Listen just a second, because we don't speak about exams. You need about expertise. Because year 1 and 2, you will learn material resistance, electronics, and this and that. So in the year 4 and 5, you are going to get specialties. So in other words, what you are saying, Mr. Keshe, ionization and this and that, for one who doesn't have the minimum knowledge, he will look to your lecture like you go to the church and look to God. So you need to have the core knowledge to understand what.
But you're correct. You're correct. But sometimes out of the box thinking does more than the ones who are in the box. We got to look at both sides. The story of the first dome, huh? The guy who was trying to build the first dome, build the base, but he was running for months and months and years. How am I going to make a dome that it stands? He was crossing the road, and 2 little boys were playing, and he listens to the conversation. He says, because everybody in town, in the city, knew that this guy's got a problem building this dome. So 2 little boys says, if I was him, I fill in the inside with all hay all the way up to the top, and I build my dome, and when it's dried, I take my hay away. And that's how I built the first dome. So the little boy understood the problem, and the man for years couldn't. It's the same.
If
So
you don't
we
know
need
material
the
resistance, so the brick should support the weight of the dome. It will crash as soon as you take the.
Yeah, the guy knew how to do it. It's just building it was a problem.
Right.
You understand how to support it to build it. It's the same
Exactly
if you go in
what I
Rome.
was telling you. For example, if you don't know what the energy, I don't know what binding energy of the hydrogen atom is.
No. Yeah, you're correct. We are not.
And you don't know what is 1 electron volt to find out what 13.5 electron volts is. That means it's clear that you are not going to understand anything.
Yeah, but we don't know what can bring something else, because this technology is not just about plasma. It's about the environment. It's about a lot of things. Now I'm busy for past 2 or 3 days. I don't know if you know the situation in Iran is very critical with air pollution in Tehran and in Ahvaz. Thousands of people have been admitted into hospital.
I knew that this in Japan, in Tokyo.
Yeah, in Tokyo as well. But this is what is currently in Tehran. There are thousands and thousands of people in Iran are going because of the pollution. I've been thinking, I'm working on how to make a mass cleanup system that it can be given to the government, that they can replicate it very rapidly. So past 3-4 days, most of my energy is going in that way. And so we need all colors and tastes and flavors in different sciences. I don't understand how the structure of the wind and the pressure comes and all sorts of things. So somebody comes who's got no knowledge about electronic, he can explain to me this is the thing, or to somebody who understands in the group, then we can build a system for that to support. So we don't dismiss anything. Just everything doesn't go to electrons and plasmas. Bunch who understand that can stay in that, but the others who understand the medicine, the applications will come into us.
About dismissing. I'm just saying that, let me give you an example. I don't know when you did your studies in London, how was the organization in college, but in Europe, let's say 1 year of students, it's about 100 students, they're coming to the class in one shot, So basically, after, let's say, 1 year or two, all that 100 people will be able to, to teach basics and expand the knowledge and teach the prerequisite classes. So it's going to work very fast, as I was trying to say.
Yeah, but the prerequisite with our work here is that it's on a weekly basis. People like Ludmil are not coming, you have to have a holiday. This is 12, 18 hours work sessions when we research, and other time is teaching the rest of the world. These things like this will be held by the people who are with us on weekly basis, regular 2-3 hours to teach, to explain. If it's not there, to come to a group and say, this is the question which has come. We want to, in the first year, at least to 2 or 3 million. This is the purpose of setting it up. Even if we get resistance by other people, even if we get support by other people, even if we get a physicist to come in and say, Keshe Foundation website is up, by the way, we are up.
Yay.
I just gave the instruction, that's why I went off the line to go on and see what the next step is going to be brought down. So that's why I told you have to wait till I tell you. We allowed the website to go up. It's up now. We see what they're going to do, and our webmasters are sitting in the background. So we are up and going. Rick, I saw your email last night, your concern. We work within the parameter of security. It's very, very, I gave an interview to Alan Sterling on PeaceWiki. If you have time, go and listen to it. We try to explain a lot of things. I posted on the Foundation forum. If you get it, download it very rapidly, because we might get attacked for it to be brought down again.
It's on the YouTube, Mr. Keshe, the interview you had.
Yeah, it's with PeaceWiki.
Yeah.
If you have time, read the success in the Iran peace negotiation with 5+1. Within minutes, we put this. Within half an hour, we had 36 visitors. Now I see they're still at 36. and they brought the server down. The foundation plays enormous role in the background with a lot of works in the peace negotiations. We done all the groundwork. I saw one of our colleagues on the Skype at the moment. They are the people who deliver documents to the American White House, and we received the response back. So the situation is we are recognized, they use our work, and then when they finish with us, they spit us out. But this doesn't mean we have to stop. Yeah? Go back on the forum and read this Success in Iran peace negotiation with 5+1. I can take it down and just take the pressure off the forum because they don't want this to be known. Take a copy of it and keep it. This is part of the work which you lot as Keshe Foundation or supporters around the world delivered papers, went to the embassies, and in a very small way set the scene for what the peace was achieved. This is not done by me, it's done by you lot. Now we explain it, we put it further in, and we explain what this is going to bring. Our friends in Tel Aviv didn't like this. Our friends in Belgium didn't like this. Our friends in Vatican didn't like this. So this attack was so heavy, it was collective decision, let's bring Keshe Foundation down. So we are up. I just gave an instruction, we could have been up on Sunday immediately. But we have to understand, we do not create, we have to work as not a fringe scientific organization, but as a new scientific organization. The ones who have to protect their titles, they'll do. But with the teaching of this 25, 50 people or 1,000 people in a year, 2 years per year, we speed up the mass teaching. No science has ever been spread so rapidly. I'm surprised in what we see. I'm surprised in how this technology is touched millions. Millions. I get a call, it's strange. I tell you what happened. 2 weeks ago, I was in center of Italy. I live in north of Italy. I went to center of Italy about 400 or 500 kilometers away. I had a meeting for the center we're trying to set up with the banks and everything. I came out. I had to stop for lunch. I pulled up randomly in a small Italian cafe, just to have something simple to eat because I had under 4 or 5 hours of drive. While I was standing at the counter to order my food, this guy comes to me and says, "Excuse me, are you Mr. Keshe?" I said, "Yes." He said, "I saw you getting out of the car." He parked his car to come out to see. And this is in the middle of nowhere in Italy. The technology has reached the millions. Now everybody is waiting to see one generator to work and then the technology is correct. Everybody is just waiting to show us 1 kilowatt, 1 watt, then you're God. No, this is not the way it's going to be done. We showed you the life of a man who is with ILS. They told us you employed a very good actor. This man, yes, on Sunday, he has not been anywhere in a way in public for nearly 2 years. On Sunday morning, he wakes up and he decides, I'm going to go shopping with my family. He couldn't do this. So from 11 o'clock till 5, 6 o'clock in the afternoon, he's gone for 5 hours of shopping in a crowded place, in a shopping center, in a supermarket. This is the proof of technology. This is what this technology is giving a man a life to have 2 boys of 8, 10 years old, to have a father for another 10 or 20 years. He might die in a car crash in 20 years. Yeah, we all die. It's part of our process of life. But if showing a man who was in literally paralysis on the death cells with ILS, since March, 8 months, now he goes shopping. Now we are planning for him to start driving again.
Well,
then you give the life back.
that's why I think it's really important to get the translations and transcription for
It's
the
gone.
ALS video.
It's gone. Rick, I received it and it went automatically to the webmaster. I spoke with him yesterday. They're going to put it up. We had a problem with the website. Now we are back up. We don't know how long they're going to keep us up.
Right.
But now we have
YouTube is different. The YouTube site's different than the website, so it should be separate and not under the control of going down with the website. So I would like to...
No. It has to be. It's got to go to the webmaster because he does all the loading.
Even for the YouTube videos, right?
Yes.
That's the thing. They have to be able to do it.
You see, the thing is, what I can do, Rick.
Translations, they get really upset when they can't see their translations put up.
Yeah, Rick, there is something which we got to do. We have people who have infiltrated the foundation from the other side. We know who they are. We know them, what they are doing. Yeah? We have to find people who we can trust to allow access to these things that is done by them. I'd love to give you access that you control everything with the YouTube loading.
Well, that would be good. I would be happy to do that.
Yeah, but we have to find secure way of communication. We have to understand what's going on. Yeah, right. We have to. We used to do. We had, but you have to understand. We have such a heavy info. There are organizations putting a lot of time and money trying to discredit and destroy the foundation. Yeah. So we are very careful. We are very, very careful. We are very cautious. We moved the foundation security team into Tehran out of necessity.
But Mr. Kesh, if I may provide you an advice, you know that these peer-to-peer systems, you know how these movies are downloaded more or less legally, I mean, with or without paying. This could be also applied to the Keshe Foundation website. So as the traffic is going to all these peers in all these countries, they will not be able anymore to put the main website
Listen, can I ask you a question?
Yes.
Send me an email.
Okay.
Send me an email. If you're expert in this field, send me an email. Okay. I put you in touch with our webmaster.
Okay.
Share communication with him, share your knowledge, or if you know you can spread us around the website that they come bring us down. Send me an email. I'll call you back today. We can go through it step by step. Then I have to convince my webmaster this is the way we can go. At least we can try. We are looking at it. it. So if you know the ways to do it, you have my email. I presume you have my email, private email. If you don't,
no, I don't.
I don't put it on the site. Ask Rick. Can you supply him with it, please? In private?
Okay, we can discuss later, yeah.
Sure.
Yeah, get it? Come back to me. I'll spend 10 hours with you because this is something that has to be sorted. Yeah?
Okay, I will prepare a material for you regarding mirroring of your foundation website in a peer-to-peer network.
We own our own mirror. Foundation owns its own mirror. The foundation owns his own mirror, server mirror.
Okay, I will prepare the material for you and I will certainly do it.
Okay, thank you very much.
So that will take the pressure out of you.
Yeah, I cannot explain how much we've been going through in past week keeping the foundation forum down or website down because of these. If there is a way we can spread along over the internet, please take it. You can handle that with our. We need a new webmaster, more out of the security. Controlling
if
like
you allow me a joke, sir, I have to buy life insurance.
So, believe it or not, I hope it's not that heavy. I think you have understood the problem with us. You put your nail, you put the nail right on the head of it. But this is the problem we have. The problem is, as somebody said, I read somewhere, we have to be reachable by world population. We have to be approachable by a world population, and we should not become elite. I have seen emails in past week coming from all over the world. I get hundreds of emails. I see emails that this is ridiculous, but it has to be discussed because it's sitting there. They call me Messiah, and this is the guy who's going to change the world. If I was a Messiah, I will handle the computers in a different way. So you understand what I'm talking about. The process is to transfer the knowledge. Just because we look at it a different way and it makes sense, it doesn't make us God. But we have to be reachable and not to be blocked. If you know ways to bring in, a lot of people told us, oh, we can help you with your server, we offer you server space. But we knew between these people who are offering, there are people which is put in by our enemies. We did not respond to any of it. But yes, if it's this,
in my expertise, my suggestion will be to have the servers somewhere in a secure location, access to them to be through a peer-to-peer network. In this way, you will block any concentrated attacks.
Explain to me that I can understand. I can explain to our team of webmasters.
Okay. I will prepare a material for you.
Email it to me, and then I send it to them. Let them do it. We need this. We need to be able to be on the scene all the time, not just because we put an article and then we can be brought down. The very nice thing, if you read this article, which is on the forum, the line emphasizes, the last line literally summarizes the whole thing we've done in over 10 years as foundation. We achieved peace without a single bullet being shot. And you know what the threats were involved in this situation. They're going to nuclear bomb, they're going to attack nuclear bases, they're going to attack with nuclear warheads to destroy the nuclear centers. With the right approach, with reaching the right and touching the heart of the people the right way, last November in handing over a hand as a peace, we changed the situation. The whole situation changed because up to then, Americans and the whole thinking was they are the biggest enemy. They sat on the table, across the table, the room was full of security, American security officers where the meeting was taking place, that, you know, the consul or the ambassador would not get shot by me. When I put the hand of the peace across the table, it touched the heart. It touched the heart of the Americans. And within days, we've seen it. And as you know, there's been secret negotiation. Now I can talk about it. In the past, there's been 5, 6, 10 secret negotiations around the world between the different governments before we've seen this. And somebody in this forum knows the letter we received and the content of the letter we received from His Excellency President Obama in July. We did not respond. But when I received the email, my emails, the text of the letter is read by the officials. So we knew the position, what is going to be. This is the second time I've been involved in high-level peace negotiations. When I tell you how the peace is going to be done, it's not just my dream. I was involved 10 years in one of the biggest trouble positions in the world, and I got involved, and we achieved peace, and now it's a lasting peace for over 10 years. This is the second time. And we can talk peace with anybody, being religious, being financial, being borders, or whatever. We showed through your support, people like you over years who have supported the foundation, have given this groundwork. Now we have to build on it. And if you know more ways to stop others, to stop us reaching the other people, that's all we need to do. You know how to help us do it. Rick needs how to do the. Let me explain to you what the whole idea was. The whole idea was to kill me in Belgium or force me to exile. And by me being exiled, the whole thing will die. So heavy core support in Belgium was lost by us coming to Italy. But now we found a heavier core internationally. It actually brought us benefit. Now we have to what do you call it? To establish trust, and you people have to take over part of this this operation. Not me anymore. Our webmaster, we have nearly 13 people in a team of webmasters just protecting the server. You know the way to do it. Rick knows to do this. If you send you people do the translation, it doesn't go up because we're trying to keep the minimum spaces possible to use the maximum. Speak to me, I give you access to the YouTube, load up the YouTube, handle it like the Facebooks. I have no problem. I have 3 books written, complete, to be pictured, to go published, sitting for a year. I don't have the time. This exile situation creates a lot of problem. Our attack does not come from Mr. somebody in the country. It's coming from governments. Somebody has written on PeaceWiki, who in Belgium is bothering us. Why don't you? We told you who it is. The position with Belgium is very clear. We know who they are. We put the names down. We know how many scientists they've killed up to now. Scientists who come up with a new design. There was a petition was going to be put in the Parliament of Belgium. How come this organization is getting rid of so many scientists out of Belgium when they get killed? Everybody knows who these guys are. They make a living out of this way. Now, if it's a spread with you lot, and you can take different corner of the carpet, we can lift it very easy. But the whole plan was to shift us out of Belgium. We lose the base core. I consolidated. Now we're opening the institute. Now we need more people. Now the technology is spread. If you go, please go on PeaceWiki. We told you for a long time. We told you for a very long time that we be with the invitation of NASA to go to give lecture. We didn't approach you. NASA approached us. Yeah, go to PeaceWiki. I put the link now on. Okay, wait. I put the link on.
Let me give you a very short example.
No, let me tell you, because this is important. We have to clarify. This is the link. Go on this link, and then go through the video. You come. This is not on me. This is PeaceWiki. You see, because he was the guy who initiated the communication and our talks with NASA, Alan Sterling. He has put the name of the head in NASA on the YouTube, who we were not negotiating with. And his name is clearly there, and what he's done is put his picture on it. So when we said we are negotiating with NASA, someone is studying which is going to risk his neck, yeah, and he's put Mr. Nelson, his name, yeah, his name on the internet. So this is not a talk anymore. We negotiate. We talk. We negotiated. I was supposed to be in America by the invitation of NASA, yeah, for development of the technology and cooperation between NASA and Keshe Foundation and hopefully Iranian Space Organization and a Space University. These things are not, when we say we are doing things, we just don't talk, because then they say, where is the evidence? For a year and a half, we told you we've been invited, it's there, then the visa was refused, and Alan Sterling has gone a step further. He's put the actual name of the gentleman. His name is very much, I tell you, look at the, what do you call it? It is 47:18 minutes into the video, yeah? His name is there, Mr. Nelson, with his full ID of NASA. He's one of the top management. We were negotiating, we were talking, NASA called the ambassador in Belgium. They called the consul. They did all the pressures they could do
to get that we could teach the technology, because they tested, they knew the technologies, they know the technology. And after this, they received the keynote, they're doing it themselves. Yeah? The name is on. So we work, we negotiate, but we don't talk. The NASA management has got a block. The position is, as an Iranian nuclear physicist, I cannot go to a country where it's blocking Iranian nuclear technology. So we have to understand, when you see the peace talk with different world leaders or foreign secretaries sit there, go back to what we did. A handshake across the table, a piece of hand, has led us to this position. And we followed, we explained everything as it happened. Go back to Mr. Nelson. Go back, if you're in America, to NASA, because NASA has blocked any communication at Keshe Foundation. It will not. They found out themselves. They told us how they've done it. Somebody in NASA has put a block. In NASA, we didn't know. You need two people to ask for an email to be blocked, and they block it. So a woman put a block, and they went to her and says, I don't even know Keshe Foundation. So it's your job to spread the knowledge. It's your learn and pass on. I would love to ask, Mr. Nelson was threatened that he's going to lose his position and his job in NASA if he carries on in any communication invitation of the Keshe Foundation. They are threatened. People are threatened with their lives, their livelihoods. I haven't put it. It's there. Go and have a look. Because there are communications we can release. I can easily, to support my claim, I can publish His Excellency President Obama letters on the internet. But this is not the way it's done. If they do it, we say it's been done. Now Alan Sterling has put this up. He's taken a huge risk, but he knows how much he's worked in the background to set up these things. So please, you want us to work, you want us to spread the knowledge. People at highest level in NASA know this knowledge is correct. Yeah, they know this is the future. They understand where it sits. You don't put just put the position of Mr. Nelson on the internet. He is the head of the propulsion lab in NASA. He is one of the top propulsion scientists. This is the guy who brought the other guy from trying to prove his technology is correct and it couldn't be done. These people don't invite you if you're wrong. They understood the full A to Z. Our technology is 100% correct. Our technology is proven to be correct. But it's a danger to the other societies and other companies who see us as a threat, and we are not a threat because with us they can make more money. Now you write to NASA. I can give you all our correspondence to the administrator of the NASA. Why Keshe Foundation is blocked? Why can't we talk about the new technology? People at this level would not bring us in and risk their name and reputation in such an organization if they didn't know we are correct. But they have to keep silent. Now it's out. NASA, when we told you we negotiated with NASA, it is, all the documents are there. NASA did every possible way. They went out of their way to negotiate with the council in Brussels for me to be able to go to give lectures and explain and bring a collaboration between NASA, Keshe Foundation, and the Iranian Space Agency. It would not be allowed by the White House. But the White House was nice enough to ask for the key that the NASA can test it. When we tell you the technology is getting tested in NASA at the highest level, is done and they're still doing it. Good luck to them. We gave it to them free. I hope they use it for peaceful application. But I didn't do it. Now Mr. Alan Sterling Allen, PeaceWiki, has put a name out. Now NASA has to respond. We're going to see how NASA is going to respond. Why the head of propulsion lab of NASA, except the propulsion is finished, we have to look at this new system. Come and explain. NASA originally set up the lecture I gave in, what do you call it, 2 years ago, and then they canceled the visa. They wouldn't issue the visa. Johns Hopkins University. NASA knows this technology is 100% correct. Boeing knows this tech. They've seen the videos which we never show in public. The technology has been tested, and leading space agencies around the world have confirmed it is correct. Now we are out. PeaceWiki says, not me. Name is there. What's Nitson? His name is there. He's the top man in NASA, and they have made a decision. This technology has to be here in NASA because it's sound enough to be accepted, to be applied. But unfortunately, I carry a passport. It says Iranian. And Iranian nuclear physicists at the moment cannot speak with NASA. As I said to very recently, past couple of days, in fact, we should have been, as Keshe Foundation, at least be invited or be present in the peace talk in Geneva. We initiated it, but they took it and they run with it and they finished. But that's all the purpose. We don't look for glory. We don't look for, for recognition. But the recognition is there. The steps are there. We put everything step by step on the website. What happened? They asked for the key. We put it there. The people who, moved with us know what happens. And we kept it very much in open. So go and look. We need you. We need the support of you. And if you know a way to keep the technology in front line, take it with you. I have a direct telephone line to the minister who's responsible for the Fukushima disaster. They know we can help. But he's been told by the Americans he cannot work. We have to stand up. And millions of people are dying because of this position. And hopefully with this peace talk is over. There is a bigger thing is coming up. The next step in the process of the foundation is bringing the World Peace Treaty to the share of the knowledge. You want to help us come in. You want to build reactors, you have all my time. Now,
speaking of reactors, I think John might want to show some of his beautiful ceramic reactors. Would that be a good time to
Anytime, why not? We are here.
Are you ready for that, John?
I've just posted the link, and I have a couple of pictures. The beginning are the pictures you might have already seen, but I have continued. I have in fact a 20 centimeter sphere, and I have made a 10 centimeter sphere. In the pictures, I have two kinds. Those that are glazed.
The black ones.
Well, it's
the grayish color. Bluish
yes, yeah. And those are outer spheres because of the necessity only to create an plasma inside, and it won't be inside another sphere. So that's I had a different possibility there to have size, and if you look I wanted to show first, if you go to the end, I'm handing one of the spheres, and I just wanted to show that it was completely the hole you see is in fact the vacuum, the space inside the sphere you can see. I showed. If you see that, you see that I can make some work on the ceramic and have cylindrical fits on each side to be able to put the bearings, to put eventually the ceiling, and well, I can work on that aspect to have a how can I say all the parameters that can be controlled on a single sphere, I can have it put up on those ceramic sphere. In fact, the white part of those sphere is the external part, which is not glazed, and the glaze I've put is only for the decoration. I don't need, in fact, the glaze, but it was a way of showing that some decoration, not the rest. Then, if you look the few pictures just before the last one, there are different 100mm spheres. You see that two lines before. You also see that there's that sphere with two tubes on it.
Yeah.
That's to have it as an inner sphere to the bigger spheres. So I wanted to show that it is possible to work ceramic, to have one piece
inside
for the whole inside the other, and of the same matter. I don't need stainless steel or anything else to make the shaft for the inner tube, the inner sphere.
But would it hold vibration? Won't these tubes crack under the vibration?
Well, in fact, the vibration. What's happening is, in fact, the working of the on the lathe, which I have two pictures there just before. In fact, I work the matter when it's raw, because it's easy to work, and once it is a high 5, it becomes very hard, and it is resistant. So, in fact, what I could do is keep a certain thickness to the shaft. That would be only the correction in the dimension of the hole on the bigger sphere.
Wow. Kidding.
Hey guys, could you mute your mics, please?
Okay.
And
the vibration doesn't break it, so doesn't damage.
Should not. Could be. Well, I should be making some.
I think. I think you better glaze the whole thing.
Yes.
I think so, because then you have mono material than two different materials. And I think if you glaze, and that's my opinion, I could be 100% wrong. If you glaze the tubes on either end, and you're inserting one inside the other, most probably somewhere down the line you need seal to seal the different cores from each other and from outside. Then the sealing material or the sealing bearings will work much better.
Yes, I do agree with that, because the roughness of the surface will be minimized.
Yeah, so you get.
But I have been thinking of it also. You can smooth the surface, but I would need, in fact, diamond type of material on the wheel to make the smoothing. Yeah, so it is possible to do the two ways. But when you say that for the uniformity of the material, if it's not glazed, I have one material for the whole. The glaze I've been using there is only on the surface, on the external surface of the sphere. That would not interfere with the gases that are inside.
I think you better glaze the inside. I think it'll be wiser to use a glaze inside.
So, but then I should use, well, in the glaze you see there that was only for the color.
Let me explain. Let's look at it scientifically. When you don't have a glaze and you have a rough surface, and with the high rotation of the cores, and if you put gases in, you definitely need multi-layering with this system. You create a different speed in different part of the outer layer, and this will overall will affect shape and holding of the plasma in the center.
Yes. What I think is that because of the roughness inside, I'll have some turbulence really at the surface. The first layer of the gas inside will happen to have another. It won't be the turbulence will make that the surface layer won't have a correct contact with the rest of the gas inside, because of that small. It's like on a plane. You need, in fact, very little roughness. So the wing will be how do you say the layering of the gas fields, the gas flow on the wing has to have the less turbulence possible to have the lift of the wing. So in this aspect, the inside should not be rough at all. I have no control of the inside, whereas putting some glaze, but then I would have to choose a good glaze, because should I need only a glaze that contains silica, alumine, and some maybe a little bit of sodium, potassium, to have a glaze that will melt. It will have a shiny aspect inside, so it will become very smooth. But the mix for that glaze could be changed, and because the color I have there, there's some copper, there's some cobalt. That's the source of the color, but the quantity of those matters is 0.5% to 1% at most. Otherwise, the color would be too dark. So that was the external aspect of the
glaze. Can you make a mono-material glaze?
Yeah, well, a mono-material glaze. Well, to have a mono-material glaze, in fact, a glaze is always composite because there's some oxygen and there's some well, in at high temperatures you have acid materials, you have basic materials, and you have the amphoteres, which are between the two. Silica is acid. Potassium or calcium oxide, that's basic. And between the two, you have aluminium oxide, which can react as an acid or like a base. To reduce the composition of the glaze, I need silica. I need a little bit of aluminium oxide, alumine, to have the hardness and to control the melting point. And I need some material like chalk or talc that will help the melting point. So,
is the white one? What is the white one made of? It's a composite too.
That's just the basic I've just been saying now with sand. In fact, it's feldspar. Feldspar is already a composition of different. Well, in feldspar you have some silica. You have just a moment there.
Don't kill the bird.
No. I just wanted to. but when he starts talking, he wants to say, "I'm there also."
So don't kill the bird.
No. It's
John, something quickly, by the way, here are selling some kind of German knives, and they say they are stronger than stainless steel, so probably that's another good point if you want to look at it.
Yes, I know this kind of ceramic, and they are very, very hard. They break also easily.
Well, they say they are stronger than stainless steel, so
yeah, but as long as they use, no,
I have never used them, but
yeah, I use them. They chip very easy. They are very good, but if you touch a bone with them, they just chip.
Yes, in fact, the sharpness stays and won't wear, but it's very breaky. So
it's brittle.
Yes, it's brittle.
Mr. Kesh, did you heard that right now they are doing a ceramic coating to the stainless steel? There's a company in actually Los Angeles.
I tell you something. If you can coat with SP3 and nanomaterial, is one of the best. Is absolutely one of the best. You can take anything, any material, and if you find a way, or you can do the coating with nanomaterials, especially SP3, the configuration. This are one of the best you find, but I don't know if you can do it with ceramic. If I have the material, I know ways of testing it. That with the white material you have, you can nano coat it totally on its structure. But one of the problems which we didn't know with the scientists we work in Ghent University, what's his name, Professor? He tested the nano surface for us. And he said, you know,
was it Van den Meer?
No. They did some tests in the electrical engineering lab, and it was interesting to understand that we wanted to use these nano coating material for brake pads, actually for the gear mesh. And they came to a conclusion that these are best thing for the brake pads because they are like, it's a porous material and it increases the friction very rapidly, but it doesn't come off at all. So nanomaterials, even in SP3, you have a 5 dimensions, so you always have a gap in the structure. And you can use them as one of the best, what do you call it, coatings.
Diamond coating?
Yes, it's a diamond coating. You can do SP3 coating very easy with a lot of materials if you know how to do the process. I've developed the process. For me, it's fairly easy. I can even pinpoint where it's done. This changes the whole aspects of the development of coatings. I see it as an alternative.
Does that include the KT liquid kind of technology?
Applies to anything. It applies to anything.
When you said nanomaterial, you meant the GaNs material, right?
Right. Very much so, yeah. It is a GaN spot in a solid state structure.
Right. Solid GaNs.
Yeah. If you think of it, your skin behaves that way. Your body, your skin, when it's inside your body, is in a vacuum condition, and it's in a gas state. And as it comes up to the surface on the different composition of magnetic gravitational field transition to the outer skin, it becomes a matter, not a GaNs anymore, because it goes on the different condition of gravitational magnetic field of the Earth and not gravitational magnetic field vacuum condition of the body. And if you can repeat the same thing in your reactors, then you find out you make skin layers. And so this skin layers, sorry about that. In this skin layers, if you can make it into not to fall off as a big piece, but as a powder, then you achieve that very easy.
So the process of doing the glaze inside would have been to change it in another way, is to make that layering as you just talk about now.
Yes. It's just a matter of how and what material you use. If you send 1 or 2 samples to us, and then there are ways of testing it if it can be done. Even if I prefer broken pieces, because we've done this with ceramic and mirror, and we've done this with gold. You can even nano coat gold, which is gold cannot be done. You can make nano gold dust on the gold itself. You can do it with a silver. If you go back in one of the old pictures of the foundation on the archives, when it used to be a Keshe Technologies, you see a placard with Egyptian on it. The Egyptians' bird are gold, and the placard itself is of silver, pure silver and pure gold. And we even managed to coat gold with nano layers that is 100% insulator. And gold is one of the best conductors. And we show it with what do you call it, with voltmeters and ammeters. Somebody wrote, "Oh, you think you just oxidize a thing." If you can oxidize gold, I'll give you a gold medal. We do it very easily. It's a technique.
Okay.
Is that nanomaterial of gold? Is that a white powder?
No, I know what you're asking. No, it's the same color. It's transparent. I know what you're asking, Mr. Cho. No. You're after the powder of life, I call it.
Yeah, the white powder gold.
The white powder gold. I think that's more cocaine than actually a white gold.
But Mr. Kesh, if we are at this point of discussion, maybe we'd like to clarify something, because a lot of people on the internet are posting the experiment with the Coca-Cola bottle, and they saying that they put only potassium hydroxide and nothing else. It appears to me, from what you did say, that what you are naming Kesha liquid probably is quite more elaborated. I don't know if the regular person has at this point
I tell you something.
the knowledge to do it.
Yeah, let me tell you something which has happened, because there is a report by it, and the Belgian government has paid over quite a few millions to do this test. We have the copy of the report, what I call touched in a way. They interfered for us to see what we wanted, not what actually was the test. The what do you call it? The Belgian authorities, I think I've told you this before, SCK and Belgian Minister of Energy and Sciences or whatever wanted to know if this thing or this material is, or what I do is a fluke, or it's just by accident I made it. So
right,
we
but the question was...
Hold on, no, wait, I have to tell you this. So we signed an agreement with SCK, with the director of the SCK, Professor Van der Walle. Dirk can tell you, Eric, he was one of the members present when we signed the agreement with our lawyers. And we signed the agreement on a Friday afternoon, and they started the test on the Monday morning, because it was such a hurry to understand what I do. And I gave 3 different liquids to SCK, each one of about a liter and a half, a Coca-Cola size. One was the environment of the blood. One was the environment of the space, and one was the environment of the, what do you call it, galaxies or deeper space. They ran tests on these 3 liquids inside the Coca-Cola bottle. And then after 2 weeks, they came back and says, we used everything. Can you give us some more? And I said, why not? So I went and I produced more. They wanted to see I made this one off. So each one replicates the working of its own environment. You put it in a Coca-Cola bottle, it gives you the same reaction. You cannot put what you said in the body of the man. But in the body of man, there is a combination of the materials which gives a desired condition. The same thing is in the space. So the material is very, very, very complicated, but amazingly simple to make. The environment of the space can be made in a liquid, I think at the cost of about 2 cents. And the environment of the blood can be made as a liquid with about the same cost. But if you put a research value on it, there is no money you can buy. There is not enough knowledge to do this. So what you see in a Coca-Cola bottle is creating a condition. And people are trying. I know people who've tried every possible liquid in the world to see what they can make. You decide, this is the golden key, this is the golden, what do you call it, entry to the world of universe. Don't produce material, produce the condition.
Right, but my point was this, supposingly that the gentlemen in this group would like to coat with SP3, the inner parts of the whatever reactor each of us is trying to do it. And obviously for the time being is either you could do it for us or you could provide some liquid, because apparently, as I said, what is posted on the internet that you put only potassium hydroxide, that is not going to create an sp3 structure. So I think I'm not wrong.
No, you are very wrong and you're very right. I answer you in a very totally different way. What do you understand as a sp3?
Well, I think that is a structure of a crystalline, I mean, well, for carbon it's difficult to say that it's crystalline because it's not a metal, but spatial structure in a, I mean, a cubical, no, it's not cubical, it's like
tetrahedral.
Tetrahedral structure of which is having carbon atoms into the edge, not edges, in the points of joining the surfaces. I mean, this I understand, if I'm not wrong.
Now, ask yourself a second question. How can, no, this is part of learning. This is a question I ask myself. I'm not asking you to do something which I haven't done. And these things have taken me a lot of night, what do you call it, the sleepless nights to find answer for.
And coffee.
Now, I don't drink coffee. No, but ask yourself another question. And if you find the answer to that question, you will understand part of the secret of the creation. We talk about plasma to be a spherical dynamic. We talk about an atom of hydrogen to be a spherical dynamic.
Right.
Yeah. And then we talk about the carbon with so many spherical dynamic entities, field strength, making that thing we call it a carbon. Now, look at how can a number of these in a given position create a straightforward lines of fields to give you hexagonal or a square shape or whatever material you like. If you think of it, if you understand that, you have solved half of the mystery of the creation of materials. You have to, how can these, you said it, not me. You said, what was the structure? Hexagonal? Or was it tetrahedral configuration? How can you create or force in a very natural way? Apparently it's very natural because it happens every second of the life. How can you put so much dynamic spherical materials rotating to create a straight line position that you get this hexagonal or pentagon shape or whatever? Yeah.
What about percussion?
What about light?
No.
The only thing I could think
it's the
of
positioning.
is the
No. Listen to what I say. Please listen to what I say. You'll find the answer.
Okay.
You change the carbon to titanium. You change the carbon to hydrogen. You still can have the diamond structure of the hydrogen. You change the carbon to plutonium. You still get the diamond structure of the plutonium. Crystal structure. Look at the gaps. Look at the gaps, how they are positioned, what distance, and what density. And how come that they create these bonds to become crystal structure. This is the point. Diamond structure, or what we call the diamond crystal structure, is the point. When doesn't matter what entity, a universe, a galaxy, whatever, carbon lines up in balance with each other, and they can balance not only externally but internally from coexistence from each other. And this is the diamond structure. Now change the name and the elements you call it, but it doesn't change the reality of if you can bring certain packages of dynamic spherical entities together, doesn't matter how many of them, because the numbers decide if you call it a copper or you call it plutonium. To God, there is no name. We made it because it makes it easiest for us to say so 6 carbon, 6 neutron and 6 proton and the rest. We gave it a name, that package. But take the package name away. How can so many spherical dimensions materials, which are the entities, hold, and all of them have a diamond characteristic? This is the positioning depending on the strength of the field between the 2 or between the 6 or between the 10. So you can make a diamond structure from any element: gold, copper, silver, gases, hydrogen, anything you like. You have to understand the relationship.
The only thing I can think at is to have like a row of 2 parallel reactors to put them on a linear.
No, you need a full carbon structure. You need about 12, 14 reactors.
Right.
And in that environment, if you can position them, make sure every reactor makes the right gravitational magnetic field, the right distance ratio.
Right.
The environment within this thing will behave as a diamond crystal of carbon or plutonium. This is how your insulin in your body works.
So now to create the liquid, I mean, how you would position the 2, 3 chemical elements into the liquid to do what you suggested?
Measure the magnetic gravitational field of that liquid.
Okay.
They measure exactly with the copper block I told you.
Right.
Measure, then you know this is the fingerprint I have to work with.
Right. This I understood.
So you can make a crystal of any liquid.
But what I'm trying, there are some people at the University of California, right, which looks like they did what you are suggesting. They have like a organic molecule, which is, as you said, linear, and they trap inside some chlorine atoms.
Mm-hmm.
But what I'm trying to say is we as a regular people, we don't have the technological resources to do that. I mean,
well, we do it every day. When you start up your car, you create buckyballs, which have.
You know something. Yes, I said this before in a couple of talks or last talk. Look at your body. How does it make crystal structure gas? Your body makes crystal structure gas like nothing. I don't think there is a multi-billion system in what do you call it, in UCLA in your body. Your body does it naturally.
More specific, because frankly,
I said that last time. I said this last time. The body creates a condition. The odor from your body, the gases in your stomach. You know, when you burp, the smell comes out. The smell is a crystal structure gas. The odor is a gas which has got a diamond crystal structure characteristic. And what happened, because there is a balance between different, what do you call it, what I call elements, the spheres or the plasmas in it, they can stretch as much as they like. So the odor can cover the whole of the room, because
Doesn't matter how they expand, the expansion is the same with all. When the link is broken, you can't smell anymore the gas. This is the intensity of the smell is dependent on the strength of the structure which these these dynamic spheres have made with each other.
Yes, conceptually it's clear what you are saying, but
so now you don't technologically you go become a biologist, go inside your body and see how gases are made inside the body. There's enough research is done, but don't read what they write. Read with the eye of Magraths. Yeah.
Frankly, I don't know how it's done.
Put it this way: they say all humans pass the same amount of gas every day. So does the cows. Yeah, we call it methane gas. Yeah, so you have to look. You have to understand how is it. If it's so easy that the body does it, the body of a cow does it every day, and all the cows, billions of them around the world, you don't need UCLA to do it, huh? And you don't need Harvard to do the investigation. Understand the principle, understand the base and concept, and then you can replicate it. I see we are falling in numbers. We are now 2, 4, 6, 7, 9, or 8. One by one, people are going to sleep. So, is there anything else? There are a couple of things which I would like to tell you before we close. One is that we will announce further people who want to join, and the foundation has to start looking for people who can sponsor others who cannot be, or they don't have the right, knowledge to be as part of the first team. So there are people who have the understanding to be, the knowledge to be as part of the first team, but they don't have the financial means to support it. So the foundation is going to start looking for funds for these people to be able to carry on with the work. So if there is any way you can support, or you know people who can support, these people are looking for funding to further go on with the process. The other thing is the process of teaching. We'll try to keep it as much as possible very open, and in no circumstances we would like to make a situation with as you said earlier, how you're scared of your life. Enough people should know that nobody is afraid of their own lives. So yes, we need to go very rapid. The number of
people will increase, the risk will go down.
Yes, but the thing is, it has to be done in a very rapid way. As you say, I'm on the first line of fire. We take enough heat. We can take more of it. There is no problem. But now, if you are members of the Keshe Foundation groups around the world and choose, you can support one person to go through the teaching program or through the knowledge-seeking program. We have to raise the funds for these people to be able to carry on. They have the right, or we think they can, bring assets to the foundation, but they cannot financially support themselves. So we need, if it's possible, to raise funds for these people to be part of it.
What would be the best way for folks to make a donation? Would it be directly through the website, or would they contact
you? You make the donation to the foundation for this person or to an individual, and that individual goes towards his cover. So everything goes through the foundation center, and you allocate to whom you. Now we have 3 people which we need to be in the foundation, but financially they can't afford it. So we need to raise funds, and I reckon out of the 50 people, till we go into multinationals, 40 of them will need financial support. I start making calls around to see the people we need. We put the emails out to the foundation supporters around the world. that if they can support, individuals can announce who they are, or individuals can stay anonymous, and the foundation does the work. But the whole idea is with this 18, 19, 20 people we're going to take as a first group, they become teachers to hundreds more immediately. So we need to work as a team to bring
what
this.
you said, I could prepare like a package with elementary chemistry and stuff like that, you know, for having the basis for ionization, all that stuff. That if you think that this could be helpful for the entry-level people.
Then we go back to the chemistry, which we are trying to walk away because it's wrong to start with.
Oh yeah, you're right. But the guys should know what is that Planck's constant.
Yeah, you just have to use the word maggrav every time where you something else.
And the guys will fall asleep.
You have to show them a reactor floating by, and that'll wake them up.
Yeah, it is. But now we're looking for
Create a condition for some whiskey.
some whiskey. It's very easy to make. It's something. No, talking about the whiskey. What's the purpose of whiskey? To make you drunk. Why do you drink it? To make you relax and comfortable, and you get drunk with it. Yeah.
Yeah.
The regular people. The other ones are drinking for the flavor.
You can put the flavor. We know how to make odors. There's no problem. But about 2005, 2006, we had a lady who there was a problems with it. So I said to her, I made a condition that she could not feel pain, but at the same time she could let go of the stress. So unknowingly, I raised her alcohol level in the body without touching a single drop of alcohol. And the sister came to us and said, my sister has not touched a drop of alcohol, but she's as drunk as she's drank 2 bottles. I said, it's very easy. You can create the condition of drunkenness without actually touching a single drop of alcohol. It's in your body. So you want alcohol in a space, you don't need to drink it. You just put your body in a certain condition. It gives you a full feeling of being drunk.
That's gonna save me a lot of money.
Yeah. $45 the bottle of whiskey. Wow.
If you can afford it for a short time to enjoy it, go to a kinesist and ask him to massage your lymphs very nicely. You will get that feeling.
I prefer a bottle of wine.
Speaking of health issues, Elia was online on the Justin TV and listening in and so on, and she has a question regarding is there any news or information about the health workshops that were...
She's supposed to organize it. I'm waiting for her.
Well, I guess you're waiting for her.
She tells me when on time I'll appear. I'm a what do you call it, jack in the box. You just need to open it. I'll pop out. But you have to. She has to organize the time and tell me to be there. We try to be there.
Mm-hmm.
There's no problem. But what do you call it? I would love to have Eli on the first group as a medical side. I don't know how I can entice her, but she'll be fantastic.
Well, maybe just saying so will be enough to encourage her.
I hope she's listening. Eli, we need you.
Yes.
May I suggest you something?
Yeah.
I don't know if you saw that these guys from MIT, Institute of Technology, and the other guys, Harvard and so on, have something what is called open courses. That means they have a camera, and when the teacher is exposing the class, the course, in the front of, 50 people, they have there. They record and they broadcast or put it on the YouTube, so the whole world can see what that teacher did in that class.
Yeah.
Maybe you would like to consider with the first group you are saying that you are going to establish to do the same, to to record.
We are looking at it. We are looking at it. We are looking at it because if you remember in the last talk I said, I'm trying to track it.
And here,
You haven't cut out.
I'll post an article here too that I've shown before to people. I've sent it to Mr. Kesh too, I think, about online class lets students control a plasma experiment, so that people around the world could actually control an experiment, maybe at the Spaceship Institute, and others could do experiments through online. And actually,
maybe in a couple of years. I don't think we are in that position yet.
Okay.
Maybe in a year or two when more people. You see, we need people to do things.
Yeah.
Eli is on. Hi, Eli. Elia is on. I can see her. She just came on.
Let me invite her in here. Yes.
Yeah. The situation is that we need people to come and do things. I have certain hours in my life and no more. And people who come up with these ideas, why don't we do this and that? Please come and do it. We support you.
So the ceramics, would that be of any use?
Pardon?
Meaning come to Italy?
Oh, you can do it from, you don't need to come to Italy. You can do it from your place.
Okay.
You can do it, say this is the thing we want to do, and that's your part of the work of the foundation. We receive a lot of inquiries from the people who want to help, but we don't have the facility since we left Belgium to bring in. And a lot of people come to the foundation originally, oh, we want to support, and when they get hold of or they become too involved and the charity works become payment, you pay us to do this for you. Where they come initially to help, I tell them when you go to Oxfam, do you work for Oxfam for a few weeks and they say now you pay me to come in? Yeah. This is something we see a lot of people. They come to the foundation initially, but they come with a second idea of what do you call it? This become a job opportunity for me. If there is a position in the foundation which is needed to be done, that foundation covers expenses. But we've seen this so many times. People come in as we want to help. We want to see the foundation to go through this. Humanity should know. But 3 weeks down the line, humanity is a bank account and no more. So we need support. We need people to do things in their own time. And they do it for themselves. So we see a lot of this at the moment. Eli? She's there. I can see her, but she's offline. What does orange mean?
Looks like she usually uses her iPod or cell phone. Might be she can.
She could be away from
there.
Skype.
She's here. Hi, darling. Good morning.
Do you hear me?
Yes, we can hear you. You have a,
Nice to see you again.
Nice to see you. I was just saying it'll be nice if you could have you as a first team as a doctor.
Yes, be nice too. But I need some other god to help me with money to pay for it.
That's exactly what I said.
Yeah. And
So-
because of that, I didn't apply the document because I'm not able to pay on myself at this moment.
So we have to see what we can raise for you. Would you move with your daughter or on your own?
No, no need to move the kids. Kids here is okay.
Yes, it's okay. I love your accent.
Indian. And also my little sister now is like a timber for South Africa.
No, it's just that I think you'll be an asset. And if you are willing to come, I'll try to raise funds for you through certain people, if we can do so.
Okay. So we are able to talk about this and explain me what have to be done.
Let me do my work. If you say yes, I'll try to set things up, see what we can do.
If I say yes to you, you know, sir.
Okay, but what the problem is with us is trying to bring this education program or this thing together across very rapidly, and we'll see how far we can go with it. We need a lot of, now that we are going, we need a lot of solid support work, not just talk or just people who come and go.
Mm-hmm.
So we need to bring the foundation throughout the world, not just because in the past it was mainly Belgium-based, Dutch-based organization. Now is the time with opening of an institute to become international collaboration. So we need people we can trust to bring in and allow you to run the foundation.
Yeah, it's okay. Just have to say what have to be rules and what have to be done. Just everyone to know the role and what.
I think from our friend in America, we understand that you have to think this to be done, and I do it, and we leave it to you.
Okay, leave it to me about the workshop. I
To
listened
you, to you with the workshop, with Rick if he wants to do the YouTube, the other guys who come to do different other things, writing a program or doing things. From now on, literally, we are going to public. It's not just me anymore who what I want. Is what you see is the best for the foundation to do.
I mean, if you allow me an opinion based on today's discussion, which was really good, I think that that path with the liquid core reactors probably would conduct us very fast to success without so fancy equipment. So
yeah.
I will keep you posted on the progress.
Yeah,
And
then in respect to the computer web, what do you call it?
The software, right?
The way that we cannot be brought down, what we can do. You had some suggestions.
Yeah, I will prepare the material for you. And the second issue, maybe until next meeting, if you can tell me the how to say, the range of value of that sensors, the magnetic sensors, we can maybe start to look into how that software to create this kind of machines to measure the magnetic field in tri-dimensional vectors.
I think you have to come and see it. I have no clue. I studied it very in detail about 5 years ago, and when I finish with something, I forget. And I asked the manufacturers, this is what I want, blah, blah, and they took them about 3-4 months to manufacture it, to build
right,
it.
But what I'm trying to ask you kindly, every machine is coming with a book, user manuals and service manuals. If you can ask someone in the foundation to scan it for me and I can take a look, probably I can find out myself the answer, because you're saying it.
Let me have a look. I don't like to do this because then we are infringing on the intellectual rights and whatever.
Oh, okay.
So
gotcha.
I give you this is how we got to be correct with ourselves. That's the main thing. Otherwise, we carry on with the same mistakes of the past.
Next year in Europe, so probably we can meet in Italy.
No problem. So. You can see how it works, and then if you understand from it, you can develop it. I explained to you something. We were in a position very recently for the big place for the Keshe Foundation Institute. And we pursued to get hold of this place. And I said to my wife, if we pursue this way to try to get this place to help humanity, in fact, we are causing a man, because he's in a desperate position, to lose all his life work because he's in a bad position. So I cannot go and hurt one man trying to help the rest of humanity. So we stop. And if it's going to happen, he's happy to come to us. It will come to the foundation. So this is the way I work. it would have been very easy for us to go and squeeze him out as a commercial point of view. But this is the way the ethos of the foundation should be. If you are going to help the others, why should we put a man out of his house, out of his work, just that we say, oh, we have a new place? So I stepped back. I walked away from it. Because you cannot hurt somebody trying to say you're helping the others. The same with your system. If I can give you a manual, then you can copy it. These people make money out of it. If you come and have a look and you understand it and you can replicate it to your understanding, then it's a different matter.
No, I understand. Let me rephrase, because maybe I did not make myself understood. That machine will have some readings on a screen, on a printout, on something, right? Then it will say something. You have 0.1 Tesla.
You come and have a look. You come and have a look, and if you think you can do something with it, you're quite welcome, because we paid for it. It's ours. And then you can make a system for a liquid. You can make a system for a gas with a different sensitivity. You can write a program for radioactive materials. Yeah, no problem. Come on, have a look.
Yeah.
There's no problem.
I do agree with that aspect. That is to have a look and see the information available, and that will help to go further.
Right, but what I was trying to say is, if in the printout on whatever is producing the machine, right, it's saying, for example, 0.1 Tesla in the Z or Z or X direction. That is all what I need to know, because now we can order. In other words, you have to order the sensor by the range. So it's something.
Yes, you're right.
So the only thing you have to tell me is, we are speaking about under 1 Tesla or 1/10 of a Tesla.
No, we go into micron.
Micro Tesla. Okay, that's fine for me for now.
And on the other hand, on others, because we have 2 sensors, we go in hundreds of kilo. You understand? From what I understood when we manufacture, we asked it to be manufactured. There is these sensors work within a certain range, and they cannot go to another range. So to cover the full spectrum, you need 2 or 3 different sensors for each part, each string.
The unit is in Tesla?
Yes.
Well, I have a stupid suggestion. Once I get there, I have enough in this area, so it's gonna be different, I guess.
I presume so. We need to bring the talents together. We try to put this on the forum to bring it out, that whoever wants to support the foundation, to donate, or say, I take this case and I support it, and then we see how we go. But we have to be aware of our own limitations. We wanted to start the course in 14th of January. The people we are talking to and the people who can commit themselves, they think it's too short because of the holidays. We have delayed it to 15th of February. So more people have time enough to move house or whatever they are doing, to resign from their position they want to resign, or to succeed.
No, my idea was different. Once I get there and see what you're doing and thinking, all my life was being electronics, so it's gonna be easy to give you a solution about these things.
Yeah, so you come up with your assets, and we thank you for putting your life in doing what we try to do.
I don't know how I got pretty much all the equipment, but I don't know how to take it there.
The thing is, let me explain something to everybody who's listening. We asked for 20,000 euro donation, or a fee per year. All this money is going to be spent on buying equipments and making the facilities. Whatever you need, literally, you most probably pay 20,000, but by the end of the year, You already spent 50, 60,000 euros on buying equipment which you think it could be useful to the foundation. So that's where the fees will go to. Is not going to bureaucratic and other applications. We run the foundation the way it is, and we are under a lot of pressure, but we keep this is what it needs to be done. There is a suggestion that some people say, can we pay, let's say, like a quarter in advance and pay the rents monthly? Why not? That can be done. That can be organized. So the pressure is not that it has to be all in advance in cases we accept. Some people say, I would like to pay the whole lot in advance. It's all the same. So we have to find a point that we attract the right caliber of people, but at the same time, we hold on to what we have and we expand the knowledge. Any other questions, or shall we call it a day?
Yeah, or a night, in whichever case you may be.
Or whichever you may be. we've been at it for nearly
2 o'clock in the morning here.
It's about 11 o'clock here today, and I've got to do other things. But thank you very much for all your help. Please, if you can, or you can raise support for the people who are coming to the foundation. Find a way to do it. You can't do it, or we don't see at the moment you can collaborate with us for whatever reason, that we can get this thing, what do you call it, going. We have the premises. We made sure we moved into a premises to be able to do it. We have the premises. The lab is set up. People can come and set their own lab the way they like to work. We have no problem. Here is very open and it's very, very flexible to fit. There is no regime like army. This is what I've done because I'm here. You listen to. You can move the tables anywhere and you can sleep anywhere and work anytime you like, as long as we work towards the same goal.
That's a good way to go on that.
Agreed. Yeah, it sounds really good.
So please help the ones who want to come in with a foundation, that we can have everything in position that we can carry on.
Right on.
Thank you very much,
Mr. Cash.
Can I ask Eli? Eli, would you like to set up a medical one, and when?
Yes, I would like. Just you have to tell me about.
No, you do it. No, you decide.
You have to tell
decide.
You're in the driver's seat.
Okay, I will be right down.
Write me an email, give me an option, 2 or 3, and then we start with 1.
Okay, I will be right to email with suggestions, and then we'll be telling.
Yeah, and the time. Give me the time you want to do it and the topic, and we usually cover. There'll be no problem. And it's a pleasure to have you on board.
Okay, because we spoke with Rick, and we decide how to do it. I mean, technically, how will we do via the Skype, etc. So now only one thing is to join the topic and time. That's it.
No problem. I leave it to you. Send me an email. We can do one in a couple of weeks if you want.
That would be
And
good.
we do 2 weeks gap between Rick's and yours. Then we have a time. It doesn't become every week.
That's a good plan.
Yeah. Yeah, we do one with you this in 2 weeks' time, back again with Rick in 4 weeks, and then 2 weeks after with you. We do one session a month with you, a month with Rick.
Does the Thursday morning, is that a good time for you, Mr. Cash? Generally?
More or less, yeah. There is no problem. There is no problem. I mean, if something happens, we can always change it, huh?
Right. So, Eli, that'd be like...
No. For me and for Mr. Cash, we have only one time difference. And for us, it's nearly lunchtime now.
Here is about 11 o'clock, 6 to 11.
Yeah, here is 12, nearly.
So it would work well for you for 6 a.m. for Mr. Cash on Thursday. Could work for you too, eh?
Yeah, it's 7 for me.
No problem.
Okay.
That's perfect. Eli, if you send me your request for the place in the institute, then I send you a package back, and I'll try with that package to see how we can secure the financial side for you.
Okay. And also,
Okay.
I have something to tell you about this time. I will be right to the email. Okay, it's more easy.
No problem. Yeah.
Yeah. Thank you.
Thank you very much. I'll be send it to me from my email. No problem.
Yeah. Okay.
Thank you very much for everybody. Thanks for your time.
All right.
Thank you.
Thank you.
Goodbye.
Thank you. Have a great day.